Beautiful life does not just happen. It's built with love, laughter, sacrifice, patience, forgiveness. A very warm good morning to one and all present over here. My name is Srishti Miraskar. On behalf of KLS GIT Institute of Technology, welcome you all to the second day of International Conference on Advances in Material Science and Chemistry. Now I request Divekar sir to present flowers to our chief guest, Dr. P. Ashok M. Raichur sir. Now I request Dr. P.S. Kaushilgi sir to introduce our invited speaker, Dr. Ashok M. Raichur sir, to the audience.
Very good morning. I am profoundly delighted to take this opportunity to introduce our eminent speaker of the day, Dr. Ashok M. Raichur, Professor, Department of Materials Engineering, Indian Institute of Science, Bangalore. Dr. Ashok M. Raichur obtained his BA degree from Maratha Regional Engineering College, Jaipur in 1989. MS from University of Kentucky, USA, 1992. He received his PhD from University of Nevada, Reno, USA, 1996. Later, he joined Indian Institute of Science in 1997. His research interests include nanomedicine, drug delivery, tissue engineering, and 3D bioprinting. He has made outstanding contributions to the development of novel drug delivery systems. He has published 190 plus publications, 8,584 citations with H-index 47 to his credit. Currently, he is working on developing new generation of drug delivery systems for gene and anti-cancer drugs, electrolyte nanoparticle multilayer for environmental applications, nanostructured multilayer for sensing applications, development of 2D and 3D structures as features in epoxy nanocomposites. Dr. Ashok M. Raichur has been conferred with many awards and honors. To name a few here, Biotech Process Development and Commercialization Award 2003, Department of Biotechnology, Government of India. National Metallurgist Award 2003, Ministry of Steel and Mines, Government of India. Alexander von Humboldt Foundation, Germany, offered him a prestigious Humboldt Fellowship in 2004. Professor Satish Dhawan Young Engineer Award 2006 by the Government of Karnataka. National Bioscience Award 2009 awarded by the Department of Biotechnology, Government of India. Dr. Raichur is a fellow of Royal Society of Chemistry, UK. He is also the fellow of the Indian National Academy of Engineering and National Academy of Sciences, India. In 2021, Dr. Raichur was honored with Professor Rustum Chokshi Award for Excellence in Research by the Indian Institute of Science. In 2022, DAD Germany declared him as its research ambassador. Most recently, he has received the Distinguished Alumni Award from MNIT Jaipur. With this brief biodata, I am presenting distinguished speaker Dr. Ashok M. Raichur to the August gathering. Sir, welcome once again.
Do I have a mic or something? Yeah, we're using the stage. Is it on? Yeah. Yeah. No, otherwise I'll just use this. Don't do that. Okay, shall I start then? Good morning, everyone. First of all, thank you for the invitation, to come and present here some of my work. And what I'll do today is, over the last 26 years, I've worked in several different areas. And last 20 years or so, I started working in this area of nanomedicine. We started developing nanoparticles, coating polymers and things like that, but gradually moved into this area of drug delivery, and now we are into tissue engineering also. So with that brief introduction, I'll come to about the institute at the very end. Today is a very special day for us, but I'll come to that at the end. So today, let me just give you an example. I'll show you some background work, what people have done about the basics of nanomedicine. So if there is some interest, some of you could also, use this. Maybe some of you will come over and do your PhD or work in IISc. And at the end, halfway through, I'll switch over to my work. I'll give you 2 examples of how we have used this nanotechnology or nanomaterials to solve, or to at least try to solve some of the challenging problems, in various diseases. Okay. So with that, so this will be the outline of today's talk. So I will just show you the current methods of drug administration. So we'll talk about a little bit about health here, and why we need to go into these nano drug delivery systems. How do we design them? How do they work? And then finally some perspectives, about the current trends. So we all know about these diseases, right? Infectious diseases which we all face. And especially in recent times, because of the viral infections, I think we all now have become very health conscious. Then we have other common issues, especially in that cancer is probably one of the most deadliest diseases. And we also deal with the various kinds of man-made problems such as accidents, burns, etc. So we need interventions at all levels. And over the years, after Alexander Fleming invented the penicillin, I think things have gone on changing over the years, and people have learned how to handle these diseases or how to treat them. In many cases, we try to alleviate the problem. There is no solution yet, many cases, and but people are still studying. So we would like to assess this. So these are some examples of medicine that you guys use, or most of us use. So we have tablets, oral medicines in the form of both liquid and solid. Then we have suspensions that go into, let's say, nasal route, eye route, right? Then we have topical applications that we apply on our skin. And of course, we also take the shots, So there are various kinds in which we administer it. So there are enough medicines available now. So what is the need for all of this study and things like that? There are a lot of drawbacks that are associated with this. I'm sure some of you know that. Generally, when we take through the oral route, much of the drug, some of it does do the job. I mean, like for example, if you have a headache, if you take a tablet, your headache goes away in a little while, right? So it does work. But then a lot of the drug gets wasted in the process, in the body. So that's one problem. Similarly, with your eye drops, for example, the moment you put it, most of the things comes up because your eyes tear up. So with the tears, everything gets washed out. And with topical also, the amount of drug that gets inside your skin is very, very little. And this is the most effective. But then the problem is it's very painful. And it also, you cannot administer it yourself. You need help. So you need a nurse at least who can do the job. Or somebody who can be trained. For example, I used to give the insulin shot to my mother. And so we get trained and we can do it ourselves. But these are some of the drawbacks. but they do work. So can we improve on this, especially not for these common diseases or the common problems, but for treatments like cancer, for example? Yeah. So some of it works, and but there is a lot of wastage also. And the other problem that comes, especially if you look at the oral route, this is a classical graph that you get when you measure the drug concentration in the blood as a function of time, and this is like different doses. So when you go to a doctor, typically they tell us to take 2 doses, 3 doses per day. And the reason for that is because as soon as you take the medicine, there is a spike, in the blood concentration, the drug concentration in the blood, and then it drops off very fast because of its half-life. Then it goes up, the next dose comes down like this. So because of this, you are unable to maintain the concentration of the drug for a longer period in the blood or in the body, and because of that, you need to take multiple times, which sometimes is difficult. So you may forget, it may be toxic at sometimes when it is very high concentration and things like that. Or if you don't take it properly, just an example, for example, if somebody is diabetic and if you take the medicine and forget to eat your food, the chances are that you experience very low sugar concentration. Okay, so that's one of the reasons. So if you can somehow control this process, so people started looking at. So we always have what you call as there's a window, therapeutic window as we call it. And if the drug concentration is within this window over a longer period of time, that is the most ideal situation. So at the higher concentration, it becomes toxic, or there is a decreased efficacy at the lower concentration. So how do we assess this? So you have the one-time dose, you are able to maintain it over a longer period of time. So people started developing somewhere in the 60s and 70s, making polymeric particles, precipitating, encapsulating the drug molecule inside, and then when the polymer degrades, your drug also starts getting out. There are problems with this, but nevertheless, the process was started long back. So people started making that. These are microparticles, and as time went on, we ventured into nanoparticles. So this is what we would like to ideally achieve, this kind of drug concentration, and that is possible if you are somehow able to not let the drug get inside the bloodstream quickly. So you hold it in a reservoir, and the reservoir will slowly keep releasing it. But there are challenges when you have it in the blood. Because of your circulation of the blood, there are other means by which you eliminate particles from the blood. So liver, your spleen, they start eliminating these particles. So you can't keep them in the blood also for too long. So people ventured into targeted delivery systems. So I'll touch upon these aspects as we move into the next slides. I think I'll skip this one. This is just to give an idea that these are the mammalian cells, which are typically of about a few microns, and then we design our particles somewhere in this region, because we already know that viruses work, bacteria work. Okay, they invade these mammalian cells, and that's how we get infections. So we try to mimic those processes. Yeah, these are some examples of particles that have been developed over the years. So you could use polymeric particles, you could use inorganic particles such as silica, and you could also design based on lipids. And each one again has its own advantages, disadvantages. So with polymers, you can get a very nice control of your particle size, easy to modify, right? You can load as much drug as you want inside the cargo. And but there again, there is a problem of aggregation and toxicity, depending on, because one thing you should remember, whenever you are putting anything inside the body, it needs to be degraded. It cannot, first of all, it cannot stay inside the body. It has to come out somehow. And the second thing is, it needs to degrade over a period of time. And when it degrades, the degradation products that are there, they should not be more harmful than the original material. Polymers have this problem because they form oligomers, and these oligomers tend to be more toxic than the original polymer itself. Similarly, with silica, quantum dot, iron oxide. Iron oxide is useful if you are trying to do some, let's say, imaging. Instead of drug delivery, if you want to do hypothermia or something like that, you could also use it. And gold nanoparticles have been tried, But the problem with these inorganic particles is the amount of drug that can be loaded onto these kind of particles is very little, because you have only the external surface on which the drug can be decorated. You don't have internal pores. With silica, you have the advantage that you can load drug inside these pores, so there is a higher encapsulation, whereas with these you will have a very high concentration of drugs. Similarly, with lipids, there is a core inside that is formed, and in this core you can encapsulate the drug. Again, the reservoir is there, so the number of drugs that can be loaded or the amount of drug is much higher, and there are various formulations that we can do. It has a very high bioavailability. The main problem with the drugs that I just showed, the current treatment methods, is the availability of the drug itself in the body, because it gets removed very quickly, or it gets into different parts of the body where it is not supposed to go. So the availability itself is not there. So if you can somehow increase this availability and then also increase the efficacy, these are two challenges that we still face. So that is where we focus on. But again, this problem is with the low encapsulation with the liposomes. But your current the vaccine that we just took, all of us, first 2 doses, 3 doses, that was based on liposome, because that till today that is the safest material that is available. It has been proven, so people went with that because we didn't have time to do any more tests. Normally these things takes a lot of time. I will just show that, the time scales and things like that. But people went with the liposomes. This tells you the what can particles do with a cell. So we could do diagnostics. That is also a big challenge, right? So whenever we want to analyze, we know that we go and give a sample and it takes a couple of days to get the results, and we have to do it periodically whenever you are being treated. And then if you want to do, let's say, MRI and things like that, people may not have access. So there is always a need to develop a cheaper diagnostic and easy to use, so that it could be used in far-flung areas where a person need not go to a specialty hospital all the time. Therapeutic mechanisms. So when we are trying to deliver a drug, we can modify these particles very nicely so that they are taken up by the cell. Then along with the cargo that is loaded, we can also do a lot of functionalization, using aptamers, peptides, small molecules, right? We can even neutralize the surface if you want, and so that leads to targeting, So in the conventional drugs that I showed earlier, there is no targeting. So you are taking it by one of the routes, it gets inside the blood, and then it goes to the required part of the body. Part of it reaches there and does the job, the rest of it gets wasted. So to overcome that, people started looking at targeting the cargo to the site itself. But this is possible only when you have a site, right? In many times you don't have a site. So for example, if you have a stomach upset, there's nothing like you have to take a medicine which goes through the mouth, But when you are talking about diseases like cancer, then targeting becomes a very nice mechanism by which you can treat it. Of course, these are the mechanisms that happen inside. I'll come to that a bit later. These are some target organs. Since I talked about targeting, you could target brain, lung, liver, lymph nodes and bone. So these are the organs in our body. Different sizes are needed to target each one of them. You can read them here. And then we also need to deal with the surface property. So if you have some specific property, then it's easier to target these organs. And building blocks we have already talked about. So we could use polymers, lipids, metals, and of course carbon and biologicals. Carbon, although it showed a lot of interest in the beginning for health applications, it's not a good idea, because if at all it degrades inside the body, it's more toxic, harmful to the body. So my suggestion is it should not be used, So we don't work on those things. But nevertheless, for my academic purpose, I think people still study those, if you look at the comments here, they do work very well. There is some, there are advantages. Of course, for the bone, we don't need to target. The bone is fixed in the body. So as long as you can somehow put your, the particles inside, so you can treat many types of bone problems, or problems related to bone, This tells you about the barriers that are there. So if you want to target things in the body, right? So you have to deal with, let's start from here, epithelial barriers. That means you need to target the skin or something like that, tissue, So the particles will have to pass through this somehow. Then we have intracellular delivery. So as I just showed in the previous slide, the particles have to get into the cell to do the job. If they want to kill a cell, for example, so it has to enter inside. Then if you are talking about tumors, tumors are more difficult to treat, because what happens is you may reach this part, let's say the beginning of the tumor or the outer part, but getting inside is very difficult, because it's very tightly locked. The cells are very tightly locked. So getting the particles inside is very difficult. But we are working on that. People are working on it. Even my group works on that. How to get your particles deep inside the tumor so that the tumors are destroyed once for all. Because in the current method of treatment, what happens? First thing they do is, if it's accessible, they remove the tumor out and they treat that area, somehow. But during the process of treatment, depending on the stage at which the cancer is, when you are removing it or when you are treating it, some of the cells, if they get dislodged and get into the bloodstream, then the cancer will start spreading. So this is man-made. Naturally also it happens, and there are issues with that. So crossing this tissue or getting deep inside the tissue is a challenge. Then targeting immune cells, So if you can do that in the blood itself, or when the blood is there, so that is also a possibility. So these are the barriers that the particles need to somehow overcome, And we have tried to develop various strategies for that. For example, this in terms of application, we would like to do imaging, right? Then mRNA delivery, which is again our vaccine that we just took. Then we need to develop different target cells like CAR T cells. Then we have mucus layer through which they have to penetrate. And then we have the antibody targeted nanoparticles which can reach deep inside, So there are mechanisms. You should read these papers, written by especially Professor Bob Langer from MIT. He is supposed to be the father of this area. And he has published, I think, close to 2,000 papers and more than 1,500 patents and things like that. Okay, so there are two ways in which you can put these particles inside the body. One is systemic, that means you just you can get it into the bloodstream, or we could trigger it. We send the particles inside at a localized site and then we trigger the release, right? Or we could do a local treatment. For example, if you are dealing with your knees and things like that, it can be a very localized treatment. So these are three approaches which we use. And once it is inside the bloodstream, it will either be taken up by passive targeting. That means you are not functionalizing, but it uses the body's mechanism to uptake the nanoparticles. Or you could use active targeting by functionalizing the particles so that it reaches the particular site. Whereas if you are not targeting it, then you may have distribution like this inside the body, all over the body. Whereas in this case, most of it is concentrated here. So you don't want to again create toxicity in other parts of the body, which is already being done by the regular medicine. This is one slightly busy slide. I won't go through all of it. So these are the technologies that have been developed over the years. And this is from Virginia, actually, Virginia Polytechnic, and they have summarized all these processes. So I have touched upon some of them. This is the process that we use, layer by layer method, and we are working on it for quite some time. I will just explain. Pegylation was invented. When pegylation came up, it actually increased the life of the particles, circulation time in the body. And in the current scenario, hydrogels are playing a very important role. They are being studied. And of course, these have all been tried, polymersomes, etc., etc. Some are still under, clinical trials. And exosomes is a new set of particles or natural particles that are being studied now. These are basically things that come out of a cell, mammalian cell. So it's the protease that comes out. They contain very important molecules, and they are also very nice, So we could either extract these molecules out, or you could use the exosomes as they are. They are very nicely made, naturally made, So this is a summary of that. I won't touch upon many of these. People have tried all these metallic things. Metal, it's okay to use, but as a researcher who has worked on it for a long time, I wouldn't recommend it. But they are very nice to work with, So that's the summary of that. And these are the things that have been approved by FDA, Food and Drug Administration in the USA. These are some of the techniques or the systems that have been approved and are currently being used these are the names that are there, the commercial names, and then these are the particles. So you can see that there are a wide variety of systems that are commercially being used, So I won't get into too many details, but it is there in literature, you can read about it. Then comes the challenge is how do you load a drug into these particles? Okay, you made a particle now, somehow you have figured it out. One is at the molecular level we can load it so that it goes and somehow sits inside this network. We have a surface loading system, that means we put the drug on the surface like I just explained earlier. We have a matrix loading system, that means while precipitating you can also precipitate along with the drug so that it gets inside. And then we have a cavity loading system by just like the layer by layer method I mentioned, where we have a shell and then inside the shell or a liposome, and inside that you have the drug that is sitting inside. So you can encapsulate large amount of drug in both these cases, whereas here it is controlled by the degradation of this particle, whereas here once you open this shell somehow, then all these drugs comes out. Okay. So the drug here you can release slowly, but it takes time, and here you can release instantly. So there are challenges, and both can be triggered by external trigger also, whereas these two will be sensitive mostly to the pH. Yeah, again just the same thing, surface loading, matrix loading, and cavity loading. I'll just skip this slide. So once you have made this particle, you have decorated it with many things. By the way, you don't have to put any one of these coating. You can do multiple things depending on how complex you want the particle to be. The responsiveness would be to acidic environment, enzyme levels, metabolic shifts. We have worked on this enzyme level kind of thing because in many of the diseases, especially cancer, locally there will be a lot of enzymes that are overexpressed, and you can use this this opportunity you can make use of and try to design a system which is responsive only to the changes in enzyme levels and not to the pH. Then we could use exogenous triggers like light, sound, or even physical means like ultrasound, magnetic field, and things like that, and these can be opened up. So, and size, as you see, there is no lack of that. So you have different sizes, shapes, charges can be manipulated on the surface of the particle. So there is a lot of advancement that has been made in this system, and in terms of uptake of the particles itself, we have different mechanisms by which they are taken up. Phagocytosis, which is the general mechanism for very large particles. So your bacteria and other things, waste in the body, are normally eliminated by this. Then we have macropinocytosis, where they are engulfed by these kind of dendrites that are present on the surface of the cell, and they take up the particles and they are removed or they are used up by the cell itself. We have Kevlar mediated, then Clathrin mediated. So here there are kind of caves that are present, slightly dips in the cell wall where the particle gets in and then gets engulfed and to get taken up. In Clathrin there are proteins that are present on the surface which can, so if you target these properly and decorate the cells or the particles will be get attached here and then eventually they get taken up, And then we have independent processes also. Again, as you see, these are all size dependent. So this is about 90 nanometers, 120 it takes this one, and 60 nanometers it goes into this system. So you can control the size of the particle, and you can also determine the route at which through which it is taken up by the cells. And there are ways to understand these mechanisms. We can study them inside the lab. And the last part is the stiffness of the particle itself. We talked about the chemistry part. So the mechanical property of the particle also plays a big role. If it is soft, then it is easy to be taken up by the cells, put the drugs in it. And if you want to penetrate inside the tumor, then it should be slightly stiff, and if you want to have a longer circulation. So you have to play around with the mechanical properties also a bit if you want to, depending on what kind of application you are trying to use it for. And the last part, I think I already covered this. In terms of clearances, you have renal clearance, pulmonary clearance, then spleens, and then the liver. These are the typical ways by which it is eliminated. In the first pass mechanism, it will go through the liver first, then the kidneys, and then eventually through the spleens. Yeah, these are the processes that are there. Just I want to show you it takes typically, these are the things that are used, whether you want to develop a new drug or a drug delivery system. These are the kind of processes that they have to follow. And typically it takes about, even though we say, 7 years or something, but it could be as long as 10 to 12 years also many times. And most of the time when it reaches that stage also it fails. That's why drugs are very expensive in the market, because the industries have to pump in a lot of money to do this research all over again, and eventually they lose the money, they can't recover it. So they, whatever becomes successful, they charge more money for that. So this is the flow sheet. This is just overall, just to tell you that this drug delivery system, or even health related, any kind of thing that you do, all the stakeholders are here. There are so many processes that are involved. So one needs to work with people from different disciplines, So this is where the way things are going now. Whether you take your regular automation, artificial intelligence and things like that. So people from all disciplines, we no more work in silos. You cannot say you are from mechanical, I am from metallurgy, somebody is from civil. It doesn't work anymore like that. So we all have to work together, especially with the science people. So integrating science and engineering is very critical now, and people from, or you have to learn it. For example, I have learned biology and chemistry, even though I am an engineer, and that's how you tend to understand and work on more challenging problems. So let me just come. I don't know how much time I have. Another 20 minutes. I'll finish in that. We work on these two kinds of diseases, cancer, different types of cancer, then bacterial and viral infection. Today I'll give you one example of bacterial infection, how we try to overcome that, and one example of cancer. So this is the summary of the work that we do, and various kinds of drugs. And in recent years I have started working on 3D bioprinting, trying to integrate our expertise on drug delivery and trying to see if we can develop new models. Because now what is happening, you might have heard in recent times, the governments or the administrators, they are trying to ban the use of animals for testing. So we may need to develop alternate methods for that, and for that what we are developing is, the new area is called as organ on a chip. So you develop an organ from outside and you do all your testing on that one. So you don't use animals anymore. So is already US has implemented that. I think we will also go in that direction at some point of time. So for that, this 3D bioprinting is a very useful technique, Something called spheroids, tumors, you can develop all of those things. Even your tissues can be developed using 3D bioprinting. So it's a small effort that is being made from our side. So I'll explain this layer by layer technique because it's a very useful one. So we take two different charged polyanion and a polycation, and then we alternatively dip it into one of the polymers, wash it, dip into the next one, and so on and so forth, and we build multi-layers like this. Fairly easy technique to do it, not very difficult. And we could also do it on a flat substrate, and you could also do it on a spherical substrate. So it is substrate independent. That is the beauty of this process. So even if you have a complex shape like this, you can also dip it in and get a polyelectrolyte layer onto this particle, onto this system. So we do that, and then if you have a multi-layered particle, you can remove it out, this core out, and you have a shell. That is what we do. Otherwise, we can retain this particle inside, and still you can use it for drug delivery systems. These are the applications, and the primary force is electrostatic attraction. Hydrogen bonding could be used, but it's very weak. And this is the process where we create a particle, coat it, then remove the core out. In this case, it is calcium carbonate that has been there. It is removed by EDTA. Then we have loaded a basic drug. This was one of the first studies that we did long back. So we loaded BSA into it, and then we lock it up, and then we can release it. So the beauty of this process is you can open this shell whenever you want. You can load it, close it, and keep it. Then again it opens up to another stimuli, and then your drug comes out. So it's an open, like a lock mechanism, open and close, and we use that very effectively to design a number of systems. So you can use, you could use calcium carbonate like we have done here. You could use silica, you could use melamine formaldehyde, but many of them are toxic. So silica and calcium carbonate are probably the most effective ones. But calcium carbonate comes in micron size. You cannot make nano size. So we are left with nothing but silica. So we tend to use silica most of the time. And the mechanism by which it works is, because we have two polymers, we are having two different pKa values. So whenever we change the pH, one of them becomes highly charged and one of them becomes almost neutral. And because of that, there is repulsion within the layers. And when there is repulsion, the layers tend to get separated. So that is the mechanism by which we create the porosity. Either we load the drug or we remove the drug out. And these are some of the polymers. Okay, we use a combination of strong and weak because then this mechanism is very useful to us. If you use two strong polyelectrolytes, then the bonding is so strong that you cannot play around. It is not sensitive to pH anymore. Whereas the combination of strong and weak are sensitive to pH. So either you increase the pH or decrease the pH and we get the same effect, So very useful technique, and we started working on this. And as I said, we load the drug by increasing the permeability, and then we lock it up. Similarly, in a sphere, we can load it, then we can do the LBL on top of it, and either we remove this core out or we can keep the core intact as it is. Removing the core is a challenge because you may destroy most of the drug that is inside, especially if you have a particle like silica. So we have stopped doing this, and we tend to work with this system like this. And again, a release, I said there is chemical means, physical means, and biological means. Enzymes are probably the most useful to be used, and next best would be pH or the presence of a salt. Optically we can do it, but that happens only when your site at which the release has to be done is accessible, somehow, because you cannot use light. Light cannot penetrate too deep inside the body, so it's only goes up to a certain length. But again, you can take it inside through a fiber optic cable and then do it. So in that case, then we could use a optical means of releasing the drug system. Okay, two examples. Chitosan dextran sulfate nanocapsules we have developed, and normally what we do is we measure particle size, measure the zeta potential, because we need to follow the coating process itself. And then we start, once those characterizations are done, then we start working with cell lines. And in this case, this is, when we say CD, it is chitosan dextran sulfate, and then we have the empty CD and then the free ciprofloxacin, which is an antibiotic. So initially we started with this organism, and we were able to get good results, in both these cases, both in the encapsulated form and in the free form. Then we moved on to again target with different organisms. All those tests were good, because if you compare these two, they are always good, The most important thing is when we look at the concentration of the antibiotic inside the cell as a function of time, with the free drug, what you see is it is very high in the initial part and then decreases quickly, over a period of time. Whereas the encapsulated one is low in the beginning, but then it goes on increasing over a period of time. That means it is being released slowly inside the body, inside the cell, and because of that, you will be able to have the drug concentration for a longer period of time, whenever you need it, for the longest period, and so the effectiveness will be much more. So we saw that in different cell lines also. And then we started working with in vivo models where we took different concentrations. This is a slightly busy slide, but I'll tell you whichever is the important component here. So this is the only infection, right? So this is the number of organisms that you see, some 10 power 6 or something like that. And these are in different organs. So this is lymph nodes, spleen, and then the liver. And then we did with two different concentrations for the free drug, and then one concentration for the encapsulated one, 2.5. So what happens here is, so if you look at this free drug, 2.5 and 10, the 10 comes down to somewhere here, about 10 power 4. So there is some reduction. But with the encapsulated one with 2.5, you start seeing very similar results, right? Especially if you look at the spleen and the liver, so you start seeing very similar results with 1/4 the concentration of the free drug. So that means the same antibiotic, when in the encapsulated form, does a better job as compared to the free form of the antibiotic. Similarly, when you look at the number of doses, that in twice per day or a 1 dose per day, then in the 3 organs. So this is a CD Cipro is 1 dose, whereas this has been given twice, to 12 and 24 hours. So the 24-hour one and the 1 dose here, right? So you are able to see that this is much better in a single dose, whereas here you have to take 2 doses to bring it down to the same concentration. So by lowering the dosage and number of times you dose and the amount that is dosed, so you are able to achieve same efficacy in the encapsulated form as compared to the free form. And please remember, antibiotics are probably the one of the worst pollutants in the world today, because most of it gets into the environment and they tend to produce antimicrobial resistance in the bacteria, and because of that, much of these antibiotics are not useful anymore now. We ourselves have suffered in it. I myself have suffered. So once I was infected and we couldn't treat it. So when we did an assay, it went down the list. The number 14 on that thing was more effective in treating that particular drug, in particular bacteria. So that is the kind of antibacterial resistance or antimicrobial resistance that is built in because of the excessive usage. So if you can bring down the dosage, it will be a very useful thing. So we also did with the ceftriaxone, which is a drug that is currently used. We got similar results. And more importantly, in the survival assays, if you look at it, the encapsulated one is the only one that showed that all the mice survived in it till the end of the study, whereas in all the other cases there was some death that were reported. And of course, we checked out the efficacy of this, and I'll skip this slide because these are slightly detailed ones. This one is more important. So here we do the PK and the PD parameters that are encapsulated. So you see the half-life has gone up about 400% by encapsulation. Your clearance has decreased by 40%, and most importantly, this ratio, Cmax to the minimum inhibitory concentration, has remained the same in spite of this encapsulation. So that is what is very important for us, right? So with that study, we closed that chapter. Then we did one more study where we tried to use arginine as a on the outermost surface, because arginine is used by salmonella, and salmonella is very difficult to get rid of from the body. So we did all this characterization. I'll skip all of this. I'll tell you two different things here. One is the concentration. So you could see that even at lower concentration, we were able to achieve very good, the very little fold change that was taking place. And fold change means the amount of bacteria that increases. So we measure that in terms of fold. And the INOS inhibitor, because this is a mechanism that is controlled that Salmonella uses. So if you are able to put this inhibitor, then you can see that the number of cells that are produced, bacterial cells, very, very little, okay, in the presence and absence. So we were able to knock that off, And if you look in the concentration part, at the lower concentration of the drug, which is more effective as compared at the higher concentration. So we think that whenever you have less number of bacteria, so your drug encapsulated form of the drug works best, So we are able to counter that very nicely, So with that, and we also made sure that this arginine is the one that leads to co-localization. That means the particles are reaching the cell, whereas if you have amine functionalized one, very little goes, So that clearly showed that this is a very selective way of targeting the bacterial cells, And then when we looked at the distribution or the weight of the spleen itself, when we have different formulations, so you can see that in the encapsulated form, the spleen weight and in the untreated one or the uninfected one, they are almost similar, When we check the weight, the untreated one was very high, So this you must be aware that many times when you go to a doctor, when you have an infection, normally the doctor checks your stomach, this part, and presses very hard. And that is exactly, they are looking at the spleen, That will tell them quickly that it is an infection and how bad is the infection, just the spleen. So this is the last stage where it is there, and then it gets eliminated from the body. So we did different assays. I'll tell you the assay here. One is 3 and 5 days. This is a severe infection. This is a kind of normal infection. So we were able to get all the animals survived in this 5 days post-infection also. So even if you have a severe infection, this encapsulated one works very well. More importantly, in senior people where the chances of infection and treatment are very difficult, infection is very high and treatment is very difficult. So we were able to use this, this part. So if you look at these two here, they are actually overlapping here. So we were able to get all the mice survived the assay. So that means we can also treat people who are old, who don't respond to antibiotics, and even if you treat them with antibiotics, the other organs will not respond. So it's a very dangerous situation. And in fact, if you look back, if you carefully observe, when senior people pass away, most of them would be having lung infection. That is the cause of death. So because they cannot be treated. Okay, one last example of for drug delivery, where we developed BSA particles and we coated them with PLL and HA. The reason we use this hyaluronic acid is, when we look at breast cancer, they have something called CD44 receptors, and HA is quite compatible with that. So because of that, we try to put HA on it. Generally, this is done by complex chemistry. When you want to put HA onto a particle, you have to do a lot of chemistry to attach it. But we use a simple layer by layer method where we were able to coat it and then use the capsules. And we use doxorubicin as a model drug for this study. I'll skip these initial studies. We were able to load very high, and we could show that doxorubicin is fluorescent, so you can watch it. And these are the particles that we have prepared. Very nice particles could be prepared with albumin. In fact, if somebody wants to use this, it's a very nice technique. You can develop a lot of particles out of this, and our coating was quite successful. Yeah, I'll spend a little bit of time. This is the release kinetics. This is selective because only in the presence of an enzyme it releases much higher. To the pH it is less responsive enough. So that is what we wanted. And in this case, what happens? This is at two different concentrations, and you can see the amount of DOX that has gone inside the cell is very high enough, right? And this is the one that is terminated with HA, this second one. So you can see it shows the maximum DOX concentration. There is one that is terminated with PLL also, but that is, since the uptake is less, so the amount of drug also is less in the cell. But these HA receptors that are there, the CD44, if you block them, right, we first put a free HA onto that, block all the sites. Then we expose the cells to these particles. The number of particles that are taken up is very less. That means if the CD44 is absent, the cells are not taken up. They will be taken up, but to a lesser extent, very small. So it is indeed the CD44 and the HA interplay that comes into play, and the uptake is much higher. So these are some fluorescent images. I'll skip them. And this shows you the apoptotic cell, that is the cell death that has happened, and with this we could see that the maximum that could be obtained as compared to the free DOX. The problem with free DOX is it goes in and comes out very fast out of the cell. There is a problem with that. So even though it is used even today, but if you can encapsulate it, you can see from about 5 we are able to go up to 75, about 20. And then we do the tumor assay, the distribution. So the tumor had the maximum drug as compared to all other organs. And these are the tumors that have been extracted. This is one without treatment, and this is the one with treatment. So it's pretty obvious that the weight of the tumor is very, very low. So eventually it can be eliminated, So these were very good results that we got. We have done a number of studies, based around this. So these are all the systems that we have been developing in our lab, and we continue to do that. I will not go into the details. I'll just stop here, for the time being, Okay. So, oops, sorry. These are my collaborators who have been working with over the years, my funding agencies, and my students, These are the most important, this is the wealth I have. So these are the last 7-8 people are currently with me, and we have had several postdocs. Varun is still there with me, and then these two are the Inspire faculty that are currently working, in my group. So all the credit goes to my students. And I will leave with some images of my institute. I think many of you know this institute. So this is only the green part that is left in the city of Bangalore. And some more images, on a quiet day. By the way, today, and I'll come here. Today happens to be J.N. Tata's birthday, and we celebrate it as Founders Day. So if you go to the campus today, this is how you will see it in front of the main building. So we decorate it with flowers. In fact, the entire campus is decorated. And we put a garland and things like that. And probably he was the greatest philanthropist, who started 3 different things. One of them was IISc, and we continue to contribute to the nation and in different ways. And this was during our centenary where we released stamps, and this shows all the people who are responsible for starting this institute, and also, to bring all the glory. Land was donated by the Maharaja at that time. He was the one who gave the idea to him when they were traveling on a ship. That's how it started, the idea. And it was, since he passed away early, J.N. Tata, it was his assistant Padusha who took it on and then brought it into, made it a reality. Then later on, we had Professor C.V. Raman, Professor G.N. Ramchandran, then Homi Bhabha, and then of course, we had several other directors. This was Professor Satish Dhawan. So they all made this institute into what it is today, by launching. So we are, in fact, of course, I have not contributed so much, but we are the mother of all the institutions in this country, most of the research institutes. And this picture epitomizes that whole thing, and how decisions made by people at different time intervals, went on to make this country. He started the atomic program. He just missed the Nobel Prize for that DNA strand model, and of course time has grown and we have flown and we have reached somewhere, and so I leave it with this last slide. This is how it will be today, if you visit the institute. And tomorrow we have the open day where we invite all the students and families to come and visit us, and we show them a lot of our experiments. So I think with that I'll conclude. I started, I think I took 45 minutes. So if there are questions, I'll answer, but I'll be around the whole day. So I'll be happy to interact with you people at some other point of time. Thank you.
show me the first slide of yours. I want to take photo. No, then slides. Your photo is there.
What first?
Next one. Next. Where the drugs.
So all the medicine.
No, not that one. Very hard. Just. One more slide. Professor, one more slide where you have used the lipid based, polymer based, and inorganic based. Yeah, that. Okay.
So,
Yes, sir. I had one small question. So you showed us the tumor being treated. Is that a real tumor or a stimulated tumor? Stimulated tumor. Okay. Thank you. Sir. Real tumor. Hmm? Okay, sir. Okay, sir. Thank you, sir.
Sir, sir, how can we use artificial intelligence in case of in case of cancer recovery?
Till now we are still trying to understand how this cancer develops.
Okay, sir. Yes, sir.
Once you know how it develops, you can detect it very quickly, then you can figure it out how to treat it. Currently what happens, the treatment is done only mostly at the third or fourth stage.
Yes.
Sometimes it works, sometimes most of the time.
Okay, sir.
So it's very difficult to predict it.
Yes, sir.
So AI is always based on the learning method, right?
Yes, sir.
So you take your Google Maps, if you keep driving on the same road every day, like I do to my work to home, it knows only one road. It will never tell me alternate route. Google will tell me you are going only on this route. It will never tell me the other route, even though there are several routes available. So in that kind of learning, it cannot happen in terms of health treatment, especially in cancer.
Okay, sir.
It's still far away, but
Yes, sir.
eventually it will happen.
Okay, sir.
So if you know how it starts, then predicting it will be much easier. And
Yes, sir.
treatment also will be.
Yes, sir. Thank you, sir.
That's all. It's a very broad answer, but
thank you very much for sharing your precious knowledge on this topic of nanomedicine. We truly appreciate you and your time, sir. As a token of gratitude and honor, I would like to call Dr. S.V. Divekar, sir, to present memento to our guest, Dr. Ashok M. Raichu, sir.
Increase of temperature very much.
just learn is not good.
It's on, sir, actually. We'll decrease it. Sukhdepal sir, are you there? No. Sir, can you hear me? Sir, we can see you, but you are not audible, sir. Hello?
Yeah, can you hear me?
Yes, sir. Yeah, now we can hear you, sir. Sir, we'll go with a brief introduction first, then we can start with your talk, sir.
Okay, no problem. So this
Bodies are good without love, not one without water. Water is required for the existence of life on Earth as it is an essential component of all biological process. Now I welcome Dr. Sukhdev Pal sir from National Environmental Engineering Research Institute. Now I request Dr. S.A. Sangam to introduce Dr. Sukhdev Pal sir.
Good morning to all. It gives me an immense pleasure to introduce Dr. Sukhdev Pal, Principal Scientist, Wastewater Technology Division, CSIR, NERI. Associate Professor, Academy of Scientific and Innovative Research, Nagpur, India. Dr. Sukhdev Pal is currently working as a Principal Scientist in the Wastewater Technology Division of CSIR, NERI, Nagpur, and is a leading NABL accredited wastewater laboratory of the institute as a technical manager. He obtained his PhD in the area of nanotechnology from the College of Pharmacy, Seoul, South Korea, and then performed his postdoctoral research at Applied Pharmaceutical Science Research Division, Seoul National University. He worked at quite few industrial and academic research institutes both in India and abroad, including Hindustan Liver R&D Center, Nano Biosensor Laboratory at a Development of Chemistry, Chunghwa University, Biochip and Biomanaging Laboratory at Seoul National University, Nano Medicine Lab at the Research Institute of Pharmaceutical Science, Seoul National University. He is the recipient of Excellent Performance Award by Hindustan Liver Limited, Brain Korea, that is BK21. He has published more than 40 scientific articles in leading peer-reviewed, high-impact journals of international repute, has contributed more than 25 chapters, has presented more than 60 international conferences, and has delivered invited talks. He has also authored 30 plus technical reports. He has 15 granted patents to his credit as an inventor, including US patent. Apart from industrial, judicial, and regularly project, he has also been associated with the national and international projects such as Indo-EU Horizon 2020, Water Waste Project, Indo-French Networking Project, and now the Central and the State Pollution Control Boards Minister and Judiciary to resolve the environmental issues throughout the country. With this brief introduction, I welcome Dr. Sukhdev Pal to our international conference. Welcome, sir.
Thank you, ma'am. Now I request sir to start the session.
Yeah. Thank you for the actually not the long introduction, and it's my pleasure to and it's an honor to be here. I wish I could be there physically to attend the conference, but because of the travel schedule and other prior commitments, I couldn't be there physically. But thanks to the organizer and especially to Professor Kulkarni for sharing the link so that I can present the talk online. So let me first, I'm getting a feedback from here, I don't know. Is it visible now? Yeah, can you see it with a full screen? I don't know. Okay, without wasting more time, let me go ahead. So actually, I captured my window in a bigger screen so that I can have a better look on my slides. So today I am going to present about the multi-component nanostructure for multifunctional applications in the water treatment. In previous talk from Professor Raichu, We have seen how a nanostructure can help you in better drug delivery. Those are the things which I did during my PhD and postdoc for some time. And was very close to my heart, and it was very nice to see Professor Raichu's work that resembles my previous research interest. But now being in National Environmental Engineering Research Institute and being placed in Wastewater Technology Division, my institute mandate demands that I should work on some technology-oriented thing that helps to remediate the environmental problems. So you see that the nanostructures have been much talked about in. Is my slides moving? Okay. Okay. So, as you know, there are nanoparticles have been used for remediation, environmental remediation for a long time. And usually these particles are inorganic or organic in nature, but metallic nanoparticles are most popular. And it includes zero-valent metal ions, metal oxides, metal complexes.
Sir, sorry for interruption. Can you please go for slideshow, sir?
Yeah, I'm trying the slideshow, but I don't know. I made it full screen. I can see on my computer laptop screen that it is full screen, but in another window it is not coming. So I'll try one more time.
Yes, yes, better.
Is it visible now?
Yes, sir. Yes, perfect.
Yeah.
Thank you, sir.
So, yeah, but there are, these nanoparticles have been used in environmental remediation, and different mechanisms have been tried, like as a photocatalyst, as a oxidation, oxidizing agent, then in Fenton or photofenton reactions, and also in adsorption, the most common one. But the challenge is it is hard to can you please mute your mic, because I'm getting a lot of noise. Okay, thank you. So there are a lot of most of these nanoparticles, they lose their nanostructure or their stability suffers when they are actually dispersed in the environmental matrices. And they lose their structures and essentially their unique properties that arises from or comes from the structure-property relationship. So also these nanoparticles are very pollutant specific, so that one component nanoparticle actually is actually used for a particular function. That means they are monofunctional. So the research trend is to make a composite of these nanoparticles or move from a single component system to a multi-component system. So single composite can do multiple functions, just like our mobile phone. Initially, we had mobile phone only for talking, but nowadays, if you see mobile phone has actually forced a few of the very popular gadgets to vanish. Number one, our gadgets are the things that we encountered in our everyday life even 10 years back, like newspaper. Now most of the people now read newspaper. That means the internet accessibility through mobile phones. Then most of the people stop wearing watches now. Of course, it's a fashion now to see your mobile phone in your wristwatch. That's a different thing, but I think that is also going to phase out. So that mobile phone has become a multifunctional gadget with incorporation of a lot of other component that helps us to access many other things other than using mobile phone simply for talking. Similarly, in the same way, we thought if we can make a multi-component system and we can use it for multifunctional purposes. So first to begin with, how single component cells are used. So you can see here, this is just a graphene hydrogel made with functionalized with polydopamine. And you can see that it actually through absorption is removed heavy metals like lead and cadmium. And then also lead and cadmium, and then it also used for absorption of organic pollutants like rhodamine and P-nitrophenol was used. In second, then you can see here template-free formation of uniform working like or coral-like alpha FeOH holospheres. These type of holospheres are used for removal of say dye or removal of heavy metal, and even though these are single component system, but because they pre-tuned their structure in such a way that it increases the surface area, and arsenic removal efficiency also quite high. Arsenic, as we know, is one of the most harmful geogenic contamination. But if you see, these have been tried using arsenic 5. Arsenic 5 is not so toxic like arsenic 3. So it is a challenge to remove arsenic 3 from water medium. Next, if you see, there is another way of synthesis or controlling their structures. Like here, if you see, this is the synthetic process or the strategy. First, you have a carbon structure, and then you load your metal precursor, then do direct pyrolysis, you will get this kind of structure with regular iron hydroxides. Or you do in situ hydrolysis, and then you go for a pyrolysis. Now, this iron hydroxides, iron oxide, after pyrolysis, you get iron oxide. They are quite good in removal of arsenic. So these kind of iron oxide at carbon encapsulates help in efficient arsenic removal. The important thing is that these also help this magnetic nanoparticles or iron oxide for their easy magnetic separation of the solvent after use. And then also we can use it for repeated cycles. So up to 10 cycles it was checked, and only 2% deterioration in the capacity of the 10 cycles were observed. Here is another example of iron-based nanomaterials which is used for multifunctional applications. There is a zero-valent iron core, and then it was stabilized by silver nanoparticles. So it has got high stability in air because this iron oxide surface is pacificated by silver. Now, this also helped in effective magnetic separation because of the presence of silver. It also showed antibacterial efficacy and antifungal activities. And it was also used for removal of nutrients like phosphates from water. So when we talk about water treatment, there are two things. One is drinking water, other one is wastewater. So in wastewater, the major challenge is we mostly talk about removal of carbon in terms of COD and BOD, but which is not so focused is the nutrient removal, that is nitrogen and phosphorus. So this phosphorus, of course, is present in form of phosphate. So these are helped in removal of phosphate, this AgA2 magnetically. But this synthesis is not simple. Either you need a kind of templates or a pre-synthesized nanomaterial with precise size. These are some of the drawbacks of synthesis, because the synthesis is not very simple. Another example of this, if you have silica micro rods, then you can coat this with iron oxide nanoparticles, and then you can use it as a removal of multiple pollutants, coexisting contaminants in water. So some example is here, we have seen that removal of organic dyes, different organic dyes from the same medium. Here you can see a bunch of heavy metals removed using this. Also, it has got an application in removal of oil from water. So oil separation is also possible using this. And second thing is that you can also, after use, you can get it or get back this solvent or your active material simply by putting a magnet. Also, because it has got magnetic structure, so their collection after treatment is very useful, and that also helps in regeneration of the material. Then we are thinking how to make this synthesis very simple, and recently means like 2 years back, I think we published this paper in Chemistry of Materials, where we used only a two metal precursors, silver plus and iron 2 plus, and in presence of solar light, we could actually synthesize this hierarchical coral-like iron oxide nanoparticles, wherein the silver of nanoparticles are embedded. We used a simple photo oscillation strategy that actually you can see in the clouds. When you see the clouds, inside the cloud there are water droplets. Inside this water droplet, this chemistry is going on of iron. But this chemistry of iron or this particular photo behavior of iron is happens when iron is present in very low concentration, usually at sub-millimolar or sub-micromolar range. So this is the synthetic strategy. In presence of in dark there is no change. There is only iron, silver and iron precursor, only silver precursor, only iron precursor. And when we put it in light, within 5 minutes we can actually get this without putting any templates, any surfactants, any toxic chemical. This reaction is carried out in simple aqueous medium. And if you see only Ag in light, no change, and only Ag iron in presence of light, after 24 hours, some oxidation of iron to iron oxides that imparts a yellow color. Next, this is the actually evolution of the hierarchical structure. We decrease the iron concentration gradually. That means the R, that is the molar ratio of silver by iron, is got increased, and with the decreasing iron concentration and increasing molar ratio of silver and iron, we got this kind of hierarchical structure from simple to, you can see the clear structure. These are some of the characterization techniques that we use, and we could find out this material is actually ferrosulfuric oxide, and these are the XPS bands that shows the presence of Ag0, that is metallic silver, and presence of iron in +2 and +3 states. This is same thing again. We did multiple syntheses and to confirm whether this is happening producibility. This is energy dispersive spectra of the same material, and then we did this kind of thing. More closer look at the structure. If you see a 10 nanometer resolution, these are iron to see the silver nanoparticles. You can see the one-on-one plane of silver nanoparticles, and if you see here, I don't know whether it is visible on your screen, there are actually different lines in different directions. Actually, these are the crystal structure that shows this silver is actually a multi-grain composition, where we have a smaller crystallites of the differences. And this is the elemental mapping that confirms the presence of silver and iron. So this is the strategy that I described earlier. First we take iron, and there will be an autocatalytic photooxidation in presence of light. If you switch off this light, this entire cycle vanishes, disappears. So in presence of light, there will be autocatalytic photooxidation, which then subsequent generation of photoactive Fe3+, that will again photodissociate into Fe2+. So this is the photodissociation and photo-oscillation cycle, and in this process it will also reduce Ag plus to Ag0, and in this process some of the iron will also get precipitated at ferrosulfuric oxide, and then finally there is no stabilization. In this case, the Ag0 is stabilized in the ferrosulfuric iron matrix, and that's why we do not need any other capping agent to stabilize the Ag0. Now we have the removal of arsenide. As we say, arsenide 3 is more toxic than arsenic 5. So the common consensus is if some material is working for arsenic 3, that will also work for arsenic 5, but the reverse may not be always true. And we showed that from 1000 ppb, 12,000 ppb and 1000 ppb, that means in it could actually remove arsenic up to the USEPA or who prescribed drinking water standard level. So it is very pretty safe, and it works at a very, means even if there is a low concentration of arsenic, it is able to remove. Most of the paper, if you see in literature articles, they work with very high concentration of arsenic. If something works at a very high initial concentration of pollutants, that may not work at a very low concentration of the pollutant, and it is present in water. So we tested it both in high as well as very low concentration. We also showed, checked its antibacterial efficacy against some standards microorganisms. As you can see, we checked the arsenic removal capacity of this. This is very high. Means this, I would say this is much more higher than what is reported so far, including nano zero valent iron. We tried to do a kind of a mechanistic study, how it worked, why it worked, and the zeta potential measurement of this particular bimetallic shows that it has got a very high zeta potential, that is positive, and that would actually help it for electrostatic attraction between the bimetallic component and the bacterial species or any other negatively charged species. Then we studied some of the factors that could influence its removal. I did some absorption removal. I think we can skip this. And then we did the absorption kinetics. The absorption kinetics shows that this value is almost 10 raised to the 6 per ml. So this is very high. Anything greater than 10 raised to 4, 10 raised to 5 is considered to be very good. In this case, this particular absorption coefficient, which you see, it's very high, 10 raised to the 6 magnitude. In next another material that also has drawn our interest is dichalcogenides. Usually transition metal dichalcogenides. So the dichalcogenides, it is sulfide, oxide, or solenoids. So recently, if you see that among these the transition metal dichalcogenides, molybdenum sulfide, tungsten sulfide, they have found wide application in catalysis and water splitting, energy studies like this. But also it has got very, we thought of using this for environmental remediation. This is a layered structure, if you see. The aim is to increase their interlayer spacing. This is a molybdenum sulfide layer. So also we can create defect in their structure so that their active sites gets opened up for better absorption. So these are some of the wide defect-rich nano-hemostasis that has been reported in literature. Also, there is another material that is called layered double hydroxide. It has also got wide application in drug delivery, catalysis, and so on and so forth. Also, a lot of environmental application of LDH is there. But LDH, some of the LDH, they are good adsorbents, but they may not, they are not photoactive. But on the other hand, molybdenum sulfide, it's photoactive, even in visible range. And we thought if we can combine this together, and what it did, this kind of thing, layer double hydroxide structures, and then we put this, quickly incorporated CTI2. Now, CTI2 is another semiconductor, but it is active in UV range. So it is not so desirable, because if you have to use it, you have to have a UV source. So if we can make it in a visible photoactive, visible light photoactive, then this has a wider application. This kind of thing where some of the absorption will take place, then there will be photo dissociation of this, that actually of the adsorbed compound that will help in the regeneration of this. So this kind of strategy we thought to adopt. And this is, you see, this is another strategy how this heterolog junction formation helps in the stabilization of the photo carriers, of charge carriers, the electrons and holes. So I'm not going into the details of this science because it is well documented in literature. So based on this, we combined defect-rich MOS2 and titanium loaded LDH together, and then we use it for removal of different pollutants. We increase their effectivity, and these are also self-generated because of whatever gets absorbed on the LDH or MOS2 surface, that gets dissociated or degraded during the photocatalysis, and we get back the original material again for, and which is ready for reuse. So this is a synthetic scheme, very simple. So we did a simple hydrothermal synthesis to get TiO2 based aluminum, magnesium, aluminum, double hydroxides, and we also did defect-rich MOS2. If you use thiourea or thiacetamide, you can actually evaluate and create defects in the MOS2 layer. And then we exfoliated, and then we allowed it for the electrostatic self-assembly, and we get our desired material. These are some of the characteristics photographs. This is, you can see the clear hexagonal structure of LDH. These are the fine structures of MOS2 layer, and how we increase the distressing and created the defects. That is from the tail image we could find out that. And this is same characterization is going on. You can see how the defects are created here. The broken line indicates the creation of defects, and we also increase the dispacing. And some of the characterizations here you can see the clear picture of TiO2 at LDH. These small dots are TiO2, and this is hexagonal structure is the LDH particle. Now, this is same characterization. You can see the XRD characterization, XPS characterization that shows the specific peak of the elements or the components that we actually wanted to integrate, and we could successfully integrate them. Of course, the TiO2 peak is a bit small because you can vary the TiO2 loading, so it all depends. There are three components, so how, at which ratio you are mixing them together, that's important, and that actually determines this peak intensity. This is band gap that shows that the final material is actually active in a visible light range, and you can see this is solid state UV visible diffuse reflectance spectra of TiO2 that is very typical, which is active in this UV range, but LDH is not active at all. And here you see this is green line is our material, so it is active over a very wide spectrum. So that means we can use this material in solar spectrum or in visible light. These are some of the results for removal of positive as well as or cationic and anionic dye, because LDH and MOS2 they have different charges. So each of them helps in removal of either of these dyes. But when you use only MOS2, then only cationic dye will be removed. When you use only LDH, then anionic dye will be removed because LDH has a positive surface, MOS2 has a negative. But when you combine them together, if you see this then it can remove both of these cationic and anionic dyes, and also if you see in the presence of dark and light, both it works. Actually in light it efficacy increases because of the photo dissociation of these dyes. These are the recycle and reusability tests. We checked that their efficacy over 5 cycles for rhodamine B and Congo Red, and these are the structure of the used material that shows that these materials are still present, that they are still present. That means they are stable in water medium. So, and these are some of the absorption studies. I think we can skip this. These are the whole main idea of this, where the hydroxide, then absorption, then, so this is a dual modality action that we achieved for multifunctional application. The dual modality means there are two different mechanisms going on. One is absorption, other one is photocatalysis, and we could achieve actually multiple means removal of say dye, but they are of different physicochemical characteristics, but they could be removed simultaneously using a single component material, and material has self-degenerating ability. These are some of the mechanistic studies using the scavengers, what are the main what is the responsible reactive oxygen species that actually help in this kind of photodissociation. And then now we thought of using this for heavy metal removal. You can see there are 17 heavy metal mixtures were used, not a single pure heavy metal solution. These material was tried for a competitive absorption of 17 heavy metals, and you can see the very selective absorption of silver, barium, bismuth, copper, and lead from a competitive solution. But if you use these in a single material in a single heavy metal solution, the absorption capacity which you did here is pretty high for both silver and lead. These are some of the data that we arrived for these 17 heavy metals. They are percent removal and the KD value. If you see the KD value for silver is 10⁻⁷, KD value for barium is 10⁻⁴, or bismuth is 3, for other it is low. So these are not selective only for this kind of heavy metals. This is the simple schematics of our cartoon of that whatever we did so far. There. Next material that I would like to present, recently a lot of what is that? Instead of using this granular activated carbon. Now, granular activated carbon is the most widely used absorbing agent or absorbent that is used in the water treatment. But the problem is to synthesize this granular activated carbon is from fossil fuels is a problem. So, if we can make this activated carbon from a biomass, and then it will be really interesting, because biomass or these agricultural residues, which is actually waste, which you can see in Delhi stubble burning, if you can use that kind of biomass, convert it into a product which can be used for say for some environmental application, then it will be really good. So in this direction, we took peat, which is a kind of a moss. We first made an activated carbon of that, and then we activated that using did sulfurization and subsequent magnetization, because magnetization helps in easy recovery of this material after their use. And then we use it for contaminants of emerging concern, that includes antibiotics. Professor Raichur also said that nowadays common antibiotics are the major pollutants found in the environment, and that's why their regular use is almost limited. People are thinking of a new drug delivery system for effective, delivery of antibiotics. So we also used this material for removal of CECs, that is antibiotics, anti-epileptic drugs. And what we did first, we made this peat-based activated carbon. We did activation and magnetization, and then we did some process optimization using response surface methodology. And here you can see how this material can be recovered with placing a magnetic bar. All these carbon will be occurred here, and you can collect it and regenerate it, and you can reuse it. So these are the sulfurization steps: simple boiling with refluxing with strong sulfuric acid, and then after magnetization. Of course, before this, there is a pyrolysis step to make the activated carbon, and then we followed the magnetization step, which is done by ferric and ferrous solution, and then stirring and heating, and finally centrifugation and getting that, and of course it is washed with ethanol to remove any other impurities present. And then You can see there is a magnetic separation of this. This is dispersed in water, and we place a magnet here, and all this will be collected here. These are some of the same pictures and with the elemental compositions. We can see originally or the virgin activated carbon from which we got from the peat-based biomass. And here is the incorporation of iron. Of course, surface area is also increased from 501 to 723. Here I would like to mention one thing. Usually we use nitrogen to make determine the surface area, but nitrogen has a higher radius. That we underestimate the microporosity of this kind of structures. So often people means CO2 can also be used to measure this surface area. Okay, so if you use CO2, you actually also measure the surface area using CO2. This 723 will go to up to 1100 something. So what I want to say, if you use nitrogen, that may underestimate the actual surface area of your material, but CO2 will give you slightly little better result. But whatever gas you use for absorption, it is very difficult to measure the actual surface area or the surface area. These are all the indication, and of course this indication is sufficient for us to compare whether this material or the other material, which one has a higher surface area. Then we did some express characterization to show that the incorporation of sulfur peak, then iron peak is of course there, which is also put by UDEX, and we did the zeta potential. It has got a PZC, a point of zero charge around pH 5. So that means below pH 5 some mechanism will work, and above pH 5 some other mechanism will work. And we also characterize this what are the forms of iron that got deposited, and we are happy to get alpha Fe2O3 actually got impregnated in this, and this is an IR characterization. These are some of the study we did with ciprofloxacin and sulfamethoxazole. Sulfamethoxazole, I guess it's the psychoactive drug, and sulfamethoxazine is an antiviral. So we did the design of experiments taking adsorbent dose, initial concentration, and sorry, which is not ciprofloxacin, it is caffeine. And then we did sort of examining the what is the influence of only these parameters. One is adsorbent dose, then initial concentration of the pollutant, pH, and temperature, and how they are influencing each other. We did a design of experiment through RSM, and we did some batch studies, and we measured these at very low concentration using ultrafast liquid chromatograph, and these are the results for caffeine based. This is the modified material, and this is the virgin material, virgin activated carbon. As you can see, for both, the modified material is much more active. And these are some of the ANOVA or statistical analysis that we did with those data which we obtained. I will just skip this. And this is response surface curves, 3D response surface curve, to show the interaction of different parameters and how they are influencing each other. Without doing a lot of experience, this kind of statistics helps you to optimize your process. And this is a regular practice in our laboratory. And that also helps to save time and a lot of costly chemicals and energy of the students. So this plot is the predicted value, and this is the actual value. If you see, there is a pretty much what is that means they are in pretty good in line with the predicted value and the actual value. They coincide very well with the R square value is more than 0.9 for this. And if we did some of the absorption studies, here again I would like to say, usual trend is to fit your data with a linear form of this equation, whether it is Langmuir, Feneley, Stemkin, dividing over the P, any also term equation we take, we usually use linear term, but there is a non-linear form. So this is actually we did after receiving a suggestion from an expert. We also tried their non-fitting our data using the nonlinear form of these isotherms. And it actually revealed many new things. It is not necessary that the linear form will fit to this. Sometimes the non-linear form, which do not put any boundary conditions to for fitting this data, reveals much better information. We are not going this numbering of details. Then this is the kinetic study. We tried 3 different kinetic models. What is pseudo first order, pseudo second order, and interparticle diffusion mechanisms for both this. And if you see that each of our study reveals that pseudo second order kinetic model fits best to explain this kind of absorption behavior, and also that interparticle diffusion process is the rate limiting step in this kind of absorption thing. And this is thermodynamic study. We evaluated or calculated the thermodynamic parameters, delta H, delta U. This is usual practice. Every people do this. There is nothing novel, but that's the routine. Now, this is the economic viability and regeneration studies. The same material we used for 4 cycles, and you can see almost 94 to 97% removal could be achieved using the same material. And the collection is very simple. After use, you put a magnet, collect your adsorbents, you take it, you regenerate it using alkali, and then you use it. So this kind of material has a economic viability because this could be regenerated and reused. Unlike the granular activated carbon, that they are either regeneration is a challenge of the spent adsorbent. This is not so in this case. And this is some of the mechanistic study that we try to explore how it forms bond with sulfur methoxol or caffeine through sulfur species or double-double interaction or hydrogen bonding, and also pH dependent behavior of iron oxides also help in removal, efficient removal of these pollutants. And with this, we come to a conclusion that this material could be used for efficiently for removal of these contaminants of emerging concern. Or of course, this is not the end. Some of our students are continuously working on that, on developing different biomass-based biomaterials, and we are trying other CCs. If you see our other publications from our group, and this in the EU project, we also explored that. We identified the different CCs that are present in CS treatment plants. We did it in Delhi, we did it in Nagpur, and throughout the country. And we did that mapping first, and what are their magnitude at which they are present in the environmental matrices, and how to remove them. This is another thing we recently filed patent on this. This is we make simple silver and polymer composite, wherein this silver halide from or silver chloride is encapsulated inside a cationic polymer, and we use this for both for coagulation as well as for antibacterial efficacy. The idea was to do coagulation flocculation, the very basic water treatment technology, and combining this with the disinfection. So this combined coagulation, flocculation, and disinfection. We did, as you can see, this has got very high zeta potential. In fact, in some of the cases, if you can just vary this in, this could be as high as plus 60 or plus 70 millivolt. And we did a lot of study for removal of organics, for removal of turbidity, for removal of color, removal of different bacterial species using original simulated wastewater. And finally, last year we filed that patent through CSS. And with this, I came to, I've come to the conclusion of this talk that effluents coming from many industries may contain various types of pollutants, microbial contamination, and then potentially toxic organic pollutants, heavy metals, where monofunctional nanocomplexes show restricted performance, but if we use a multi-component, multi-system, which can serve a multifunctional, which can serve as a multifunctional material, then we can kill 2 birds with 1 stone. So with this, reached the end of my presentation. So I acknowledge my collaborators and the directors of the movie. This was this photograph was clicked in 2020, just before the lockdown in BELAGAVI, Goa. Many of the work that I presented here is done by this fellow. He completed his PhD, and rest of this is our group, rest of the group in different times. Group sizes changes with time and composition, but our line of work remains same. And with this, I thank everybody for your presence listening. Thank you. And if you have any questions, I'd be glad to answer. Thank you.
Hello.
Yeah.
Yeah, thank you very much, sir, for your nice presentation. Yeah, if there are any questions related to the topic, and we are very much interested in your research area, because we are also working on ion exchange resins. So definitely we'll be in touch with you, sir. Yeah.
Sure.
If there are any questions?
Hello, Dr. Paul. It was nice presentation, but I want to ask a general question. See, most of the time people use visible light sensitive catalyst.
Yes, sir.
And visible light is hardly maybe 10 hours we get.
Yes, sir.
And most of the time we have dark condition. So is there any catalyst which can do the same job during night time?
Okay, so recently our European collaborator, they are more interested in SOLIS. SOLIS means it is solar disinfection. So what they do in resource poor area, mostly in Africa and in other parts, they put water in a transparent container and they put it in sunlight, because they have abundance of sunlight.
Yeah.
And the idea is that to utilize the maximum time without spending any energy or a lot of money. So they were trying to synthesize kind of a transparent jerry cans that will allow the light to pass through. But this paper will be coming very soon in one of the journals, and chemical engineering journal, that you can see that transparency is not everything. Even sometimes the translucent container, they give much better results. That means you have to see that the spectrum of light is huge. It has got UVB, UVA, UVC, and visible light. So something which is responsible for killing the bacteria, that whether that penetrates through the line, whether that material which is optically may appear it is translucent and not transparent, that may be actually transparent to a particular spectrum. So as you say, of course we get only 9 hours of light in daytime, but also if you see that time there is no cost, and we can use that light. But in night time, if you used to have use photocatalyst, in dark condition, of course, photocatalyst will not work. But in that case, we can arrange for some simulated light in visible spectrum, and I think that will be less costlier or cheaper than making a UV arrangement, because UV arrangement is costly. In fact, in my pilot scale, I have I tried to install only 2 UVC lights, but of so 80 watt, but I couldn't. I had to put four tubes to get that efficacy, and in India that is also very costly. And recently we are also moving from simple UVC to LED UVC. Now in India there is nobody who can make actually LED UVC. So we actually import it from China and we use. But of course, through this Indo-European grant, DST is kind enough to sanction a lot of money so that we can build up this facility. It is now being manufactured by a company in Hyderabad, who is actually also a product of IIS Bangalore. So so this is how we are trying to cut down the costs, sir. Of course, in night time, without light, photocatalyst don't work. We are right, sir.
Okay, I know.
Yes, sir.
Yeah.
Yes, sir, yes.
Yeah, there is one paper, titanium oxide and molybdenum oxide. Composite material can work in the night time.
Okay, yeah, I would like to see the material if it can work, because titanium oxide is necessarily, it works in UV region, and no doubt, but molybdenum sulfide, of course, it has got wider range, and usually molybdenum sulfide works as a co-catalyst. It's not a complete catalyst. So I have to look into that, and if there is something, that will be very wonderful if it can work in night. Yes, sir. Your voice is not coming, sir.
The AGFE system
Yes, sir.
also can do something in the night time. So
Of course, it can work in night time.
Yeah.
It has nothing to do. Only the synthesis part needs light, but the material is equally working in night or dark, any condition. Okay, light or dark. Only the AGFE synthesis, it is catalyzed by the light. Nothing
that's
else.
okay, that's okay.
Only the synthesis. Yes.
Yeah, yeah. Okay, that's okay, thank you. We'll discuss some other.
Thank you. Yes.
Hi, sir.
Yeah, hello.
This is Harish from GIT. It's a very informative talk, sir. Hello, sir. Am I audible?
Harish, please tell me. Yeah.
So I want to know, you have produced many patented products. So are they available commercially?
No, patented products, yeah, of course, nano zero valent iron is commercially available for removal of arsenic. It's a commercial product. You can get it in market, nano zero valent iron based product for removal of arsenic. But other products, people just patent to protect their intellectual rights. But our intention is to bring it to the market, and that's why if you go to, in fact, nowadays incubation is very popular in the entire country. Many people have their incubation, institute have incubation center. Also, if you visit our institute's website, you can see there are a lot of licensing of different technologies developed by the institute. So if anybody is interested, then we can give them the license and they can go for marketing of the product. Yeah.
So thank you for the nice presentation, sir. So there are no more questions.
Also, thank you.
Yes,
Thank you.
On behalf of everyone, I would like to thank you for your wonderful time and valuable session on multi-component nanostructures for multifunctional application water management. Thank you, sir.
Thank you.
Let us have a tea break for 10 minutes and continue further sessions. The tea is arranged in the backstage. After 10 minutes, we'll continue with the next sessions.
Hello, sir. Yeah, Professor Divekar from GIT, Gupta Institute of Technology.
Yeah, good morning. How are you?
Yeah, good morning, sir. So, your session will start in another 10 minutes. There is a tea break now, right now. Okay.
Okay.
Yeah, yeah. So, how are you, sir? Everything is fine in your place?
Yeah, everything is fine, but today holiday for me. It's good for me.
I see. Very nice. So, it's a right time for you to present. So, you are comfortable today at home or the office?
Yeah. No, just now I finished one PhD Viva with the Colombo University.
I see. Okay. Nice. So, you came to India or just we didn't have any contact afterwards? I think you told me you were going to be in touch with me and then nothing happened. Yeah.
No, actually, I came to India. Actually, my son joined with the medical college at Madurai.
Where? Which place?
Madurai.
Madurai, nice place, huh? Okay.
Yeah. So I was busy with his process, long process, NEET and admissions, so many things. I could not hear your voice.
Hello, you can hear me now?
Yes, sir. Yes, now.
I think Madurai Medical College is very famous, it seems. Huh?
Yeah.
Yes. Nice to know it. So congratulations to him.
Thank you.
Yeah. So by now when you
Still your voice is not clear. Some problem with your mic.
now you can hear me?
Now I can.
Now it's okay. So now when you're planning this year to come back to India?
Yes, no problem. Maybe in the semester break. Summer. So still your mic is not working properly. Better to change the mic.
Hello, sir.
Yes.
Yeah, I think these mics are not working well. So,
Or better to use your laptop mic, no problem. Instead of using the mic.
now I'm using different mic. I think it is very clear to you now.
Yeah.
Yeah. So we'll start the session under 5 minutes. Just all are gathering again back in the hall. And actually, yesterday our inaugural function was the representative attended that also. No present. Sir, you said you are coming to India in the month of December, isn't it? Yeah. So just let me know exactly so that we can have the interactive session with our faculty as well as students in GIT. So, yeah, that's what we were expecting last time, but it didn't happen. So anyway, so this time definitely.
I'm planning to visit the month of June.
Yeah, sure, sir. Now just our CS session will start, sir. Just I'll hand over mic to my student. Okay. Yeah.
Namaste. I, Shravani Vaingankar, welcome you all for the invited sessions. Science is the best idea humans ever had. The more people who embrace this idea, the better. May I request Dr. Sudhendra Deshpande sir to introduce Dr. Rangraj Selvaraj sir.
Good afternoon. I am delighted to introduce the today's session speaker, Professor Rangaraj Selvaraj, FRSC. So he is a professor of chemistry in Sultan Qaboos University, Muscat, Oman, with responsibility for teaching, research and consultancy in the field of nanotechnology, analytical and applied environmental chemistry. Professor Rangaraj graduated from Anna University, Madras, India, with a PhD in chemistry during 1999. He has 30 years of research experience in materials, environmental science and engineering, particularly in the area of photocatalysis, environmental nanotechnology, wastewater treatment, water quality analysis, and solid waste management. He has published more than 95 research articles in reputed national and international journals and proceedings, and has been serving as the editorial board member of many international journals. He has participated and presented his research papers in several national and international conferences. Professor Rangaraj is having more than 20 years of post-PhD experience as Mary Curie Experienced Research Fellow, visiting professor, brain pool scientist, postdoctoral fellow, contract professor, and visiting scientist at different international universities. United Nations University Pilot Program and Research Institutes at Finland, France, Oman, South Africa, South Korea, and Hong Kong. Professor Rangaraj has been elected as one of the board of directors for Pacific Basin Consortium of Environmental and Health. At present, his research group is actively involving in the area of synthesis, characterization, and application of nanostructured photocatalysts for the removal of endocrine disruptor chemicals, toxic organics, VOCs, pharmaceuticals, and heavy metals from water and wastewater. In addition, he is a member of American Chemical Society, Fellow of Royal Society of Chemistry, and several international scientific committees. Recently, his name has been ranked top 2% of the best researcher around the world by Stanford University, USA. So this is a short biography. So I welcome you, sir.
Thank you, sir.
Yes, sir. Sir, please you can take over the session, sir. Thank you, sir.
Thank you very much, sir, for your excellent introduction about me. First of all, I would like to thank Professor Raghuraj and Professor Divekar and Chemistry Department faculties for giving and other conference organizers for given opportunity to deliver my lecture this morning. Shall I share my PowerPoint slide? Excuse me, shall I?
Sure, sir. Sure. You can share, sir. Yes, sir. It's perfect.
Is it visible?
Yes, sir. Perfectly, sir.
Yeah, yeah. Thank you very much. I would like to talk about the cleanup of oil contaminated water by environmental green nanotechnology. I am Professor Rangaraj Selvaraj, working in the Department of Chemistry, Sultan Qaboos University, Muscat. So most of us working in the area of wastewater treatment, but this is a little bit different areas since I am working in the area of working at the Middle East. The oily treatment is most important. Therefore, my research group recently moved in the area of treatment of oily contaminated water. This is Sultan Qaboos University aerial view. Actually, very big campus, around 10 to 15 kilometers area. This is the library area. Here, this is the administrative area. Here, this is administrative building and the Vice Chancellor's building. Here, various colleges, College of Engineering, College of Science, College of Medicine, College of Agriculture, College of Arts and Science. So, in this area, staff quarters, my house is in this area. This is a University Clock Tower. Very beautiful campus. You can visit my campus at any time. So, this is the night view of Sultan Qaboos University. Okay. Green chemistry is the sustainable chemistry and a non-polluting chemistry that we know very well. Green nanotechnology refers to the use of nanotechnology to enhance the environmental sustainability. You know, our earth crust is surrounded by 97% of the water. In that, 3% is fresh water, and the further we can divide it to 29% groundwater and 70% ice caps and glaciers, and 1% is for lakes and soil moisture and river 1%. So, water pollution is due to radioactive substance and sewage and wastewater and agricultural activities. But water pollution is due to oil also recently arising. So water pollution by agricultural, sewage and wastewater treatment and radioactive substance and oil pollution. As I told you, now we are mainly concentrating on oil pollution treatment. For water and wastewater treatment, a number of methods are available. Absorption techniques, membrane technology, solvent extraction, chlorination, advanced oxidation. The problem is that most of the treatment technologies are simply transferring the pollutant from one phase to another phase. That is simply accumulating, concentrating pollution from aqueous phase to solid phase. Therefore, we need a recent trend of treatment technology from destruction of pollutant to eco-friendly end product. Actually, as we may know, in the March 1989 and April 2010, two major accidents happened. The Exxon Valdez oil spill, the Deepwater Horizon oil spill. And recently, 5 years ago, near Yellur Coast in Chennai, two cargo ships collided each other. And because of that, you can see this picture, lot of oil spill and how the people are cleaning. The reason, until today, we do not have enough good technology to clean the water. See, using bucket, they are cleaning the water. Is it possible to clean the ocean with a bucket? And also because of this oil spill, many aquatic animals and aquatic environment destroyed completely. So because of this incident, that day I thought, why we cannot apply the research to something to create some new technology to clean the water. Of course, I am chemist, I am not an engineer, but even though if I am chemist, I have created something new. So the problem is, main problem, because of this oil pollution, as I told you, total aquatic species, aquatic environment, aquatic animals, everything destroyed. Therefore, we need green, sustainable, and easily available technology to clean up the oil contaminated water. There are two ways to clean the oil. One is degradation, another one is separation. If it is a small treatment studies, we can use the advanced oxidation process. But for large scale, it is not possible. Advanced oxidation process. If it is Large scale, we can go for separation side, that is biological methods, physical methods, and chemical methods. As a chemist, in the chemical method, I want to do some modification of surface and materials, or we can use the activated carbon for the separation of oil. So in the chemical method, what we have done in our laboratory, we use a filtration as well as absorption. Absorption means we have used modified sponge to remove the oil. For filtration, it is easy. We use this various nanostructure material coated mesh for the separation of oil and water. Really, it is interesting studies. So the chemical modification, there are two methods, physical modification and chemical modification. So as a chemist in the laboratory, we have done chemical modification of meshes. That is the coating of nanostructure materials on the stainless steel mesh for the separation of oil and water in the batch studies. So for separation of oil and water, we need to create the hydrophobic surface on the stainless steel mesh. So this is for this, the contact angle test is most important. What is contact angle? Actually, the angle formed between the surface and the line tangent to the edge of the drop of the water is called the contact angle. So here you can see, for complete wetting, it is a 0 degree. If it is good wetting, 45 degree. If it is bad wetting, 95 degree. So here you can see what for contact angle we can classify. Hydrophilic, that is less than 90 degree, water loving. Hydrophobic, greater than 90 degree. And super hydrophobia, water hatting, super hydrophobic, greater than 150 degree contact angle. In our laboratory, we tried to develop the super hydrophobic surface on the mesh for the separation of oil and water. Actually, the inspiration, we got it from the lotus leaf effect. All of you might have seen in the pond, in the well, so the lotus leaf, the surface, super hydrophobic surface, the water angle is 160 degrees Celsius. So here, as I told you, because of oil problem, we are facing a lot. We don't have enough good technology. We developed something here. Actually, the research motivation, we need green technology. It has to be stable, and we need low-cost techniques and easily available method, and it has to be high efficient, and it has to give the fast result. These are the most important. Since we have developed a lot of 2D nanostructure materials, we wanted to use the 2D material for the separation of oil and water. The reason is that it has high surface area, more surface active sites, and good electron transfer platform, and excellent photocatalyst too. So this is the structure of the 2D graphitic like carbon nitride. So the advantages of this method is it is visible light response and suitable band version. It has more chemical stability and it is non-toxic. Particularly, this is metal-free semiconductor. So therefore, it is green material. We can use it for green nanotechnology methods. So we have prepared the graphitic like carbon nitride material using the various precursors like melamine, urea, and thiourea. The preparation method is very simple, just thermal decomposition. If we use the thiourea and the urea during the pyrolysis, it has to convert into melamine and then malum, and finally we are getting the 2D nanostructure material like graphite carbon. So if we use the melamine, within 2 intermediate product, we will get the final product. Therefore, I asked my student to check the yield of the sample. So she has used various precursors like urea, thiourea, and melamine. All these precursors are very cheap. That we are using urea and everything in the agricultural sector also. The product obtained from melamine has very good yield. We got nearly 31% when compared with the urea and the thiourea. The reason is that if we use the thiourea and the urea, it has to pass so many intermediates. Therefore, it loses a lot of products. When we use the melamine, within 2 intermediate product, it has converted into graphitic like carbon. That was the reason we got a very good yield the sample prepared from the melamine. I always ask my students in the research lab, please, whenever if you do any reactions, you should know the stoichiometric chemical equations. Don't mix any chemicals according to the previous literature or whatever it is. So this is the stoichiometric chemical equation for the preparation of graphitic like carbon nitrate from the various precursors like melamine, urea, and thiourea. So these are the same images of the graphitic like carbon nitrate prepared from the various precursors. Here the graphitic like carbon nitrate prepared from the melamine shows the very good structure. So after preparation, routine characterization techniques to know the purity and quality of the prepared material. So we have adopted the XRD, SEM image, XPS, UVDRS, BET and PL emission spectra. So this slide shows the SEM and 10 images of the graphitic like carbon nitrate prepared from various precursors. Here all the images shows a sheet-like structure. However, the texture and the morphology of the samples varied with the precursors. So this is the UV visible absorption spectra of graphitic like carbon samples prepared from various precursors. Almost all the samples are showing the similar value 2.7 to 2.9, which has strong agreement with the literature value as well as the standard values. This is the XRD pattern of the graphitic like carbon. Here there are mainly two diffraction peaks at 27.990 and another one is 13.01. The overall intensity of the diffraction peaks decreases as the starting materials changed. So this is the grain size calculation of the graphitic like carbon nitrate prepared from various precursors. The graphitic like carbon prepared from the melamine exhibited the higher grain size. This is due to attributed to the easier growth of the 2D nanostructure in the case of melamine as starting materials. Here, as I told you, in the preparation techniques, if we use the thiourea and urea, it has to pass so many intermediates. That is the reason sometimes the texture and the morphology, everything is varying. If we use the melamine, within two intermediate steps, finally we are getting the graphitic like carbon. Therefore, the product obtained from the melamine shows the very good SEM image, very good XRD pattern and other thing. So this is the FTIR spectra of the graphitic like a carbon nitrate. Here you can see three major regions. The first region is the broad peak between the 3000 and 2500 centimeter per one, which is the normally stretching mode obtained from the nitrogen, hydrogen and the nitrogen H2. The second region is in the region of 1100 to 1650, which is corresponding to the stretching mode of carbon nitrogen single bond and the carbon nitrogen double bond. The third region is that peak at 885 centimeter per minus, which is the considered the deformation mode of nitrogen hydrogen single bond of cross-linked heterosynchrone units. After preparation and characterization, we wanted to use this material for application side, that is the separation of oil and water. So these are the simple steps. First, we need to clean the mesh and we need to give the acid treatment to create the rough surface on the mesh, and we need to use the binding agent which we have developed ourselves in the lab, and we have coated the nanomaterial, and again we have created the hydrophobic surface on the coated nanomaterial, and finally we applied the heat treatment to increase the robustness for separation process. I would like to show within 2 minutes this video how this work has done in the laboratory. Actually, this is more than 1 year work, but I wanted to show within 2 minutes. So my student cut the mesh which we have imported from the Korea, pure stainless steel mesh, 5 to 5 centimeter. Then we wanted to clean the any greasy material, any organic material from the surface of the mesh using the organic solvent like acetone. And after that, this is a really interesting video we have created within 2 minutes. She wanted to apply for acid treatment to create the rough surface. Then only we can coat the nanomaterial on the surface easily. Since during this COVID time, the students learned a lot of technology. So therefore, they recorded their experiment. And we used the binding agent. Then we tried with various nanomaterial for coating. We tried so many things, and she is just actually it will take longer time because of video she has taken immediately to show how we have coated. That's all. This is a coating of 2D nanostructure materials, and we have used various hydrophobic agent to enhance the hydrophobicity on the surface of the nanostructure coated mesh. So we are coating the hydrophobic solution. Now we are going to give the heat treatment to increase the robustness, stability, and everything. So now it is ready for application side. So we have used the various hydrophobic agents like DCDMS, HDTMS, and APTS. So this is the scanning electron microscope of various mesh sizes like 50 micrometer, 75 micrometer, 100 micrometer. Here you can see the surface of the mesh is very smooth. Therefore, it is not possible to coat any materials on its surface. So therefore, we have given the acid treatment. Here you can see before treatment, the surface of the mesh is very smooth. After treatment, you can see the rough surface. The acid etched the surface of the mesh. So now this is the same images of the graphitic like a carbonated coated mesh. This is the energy dispersive X-ray spectroscopy of the materials, and from this you can know the composition of the mesh. The mesh contains the chromium, iron, and nickel. So this is the EDX spectrographic like a carbon nitride coated on the mesh. So here this is the contact angle, already I told you. So we need to create the hydrophobic surface. It means we need, here you can see this is the small video. After coating, we checked hydrophobicity. So the contact angle is greater than 90 degree. Around 130 degree we got it. So therefore, we can use this mesh for the separation of oil and water. So this is the uncoated mesh. This is coated mesh. Here you can see uncoated mesh, it has the complete wettability. It means the contact angle is less than 90 degree. This is the mesh coated with the hydrophobic agent and the nanostructure materials. We have created the hydrophobic surface. So now, if it is hydrophobic surface, you can see, actually water in the video, we cannot see the color of the water. Water is colorless. Therefore, what I asked my student to mix with some dye. So this is the methylene blue dye mixed with the water. Here you can see, this is the hydrophobic surface created on the mesh. This is the oil. If it is hydrophobic surface, so here, if you put the oil, it is going down. So here, you can see this video. Now, oil, it is spreading on the surface of the mesh. If you put the water, hydrophobic, water hatting surface, here you can see beautiful hydrophobic surface on the mesh. So after that, we wanted to check the separation efficiency. If we use the uncoated mesh, we did not get a good result. All the water and oil goes down through the mesh. If we use the larger mesh, that is also problem. Optimization of mesh is one of the challenge here. We used 100 micrometer and 300 micrometer mesh. So therefore, both oil and water has gone down. So we optimized 50 micrometer and 75 micrometer mesh is suitable for the separation of oil and water. Here you can see. So the separation efficiency based on the mesh size. If it is 50 micrometer and 75 micrometer, very good separation, and 100 micrometer and 300 micrometer poor separation. And selecting the hydrophobic agent also most important. So HDTMS shows 73.40% separation efficiency. Therefore, we coupled graphitic like a carbon nitride with this hydrophobic agent. Here you can see. Using carbon nitride coated mesh shows very good separation efficiency. It is high efficient and fast and hydrophobic in nature. Within few seconds, it has separated completely. And another thing, we wanted to check the repeatability of the water oil separation. Almost 40 cycles, the mesh did not lose its property. And not only with the single oil, we tried with the various oil, toluene, mineral oil, diesel, petrol, everything. Even after 10 cycles, we did not see any efficiency loss. And I asked my student, sometimes the dye may impact any hydrophobic nature. I asked her to use the pure water, and the pure water mixed with the oil. So now you can see here. After mixing, now she is using oil and she has used water, and we checked. Now it is working well. Here you can see we separated the water. Really interesting studies, this one. Finally, I would like to conclude that we have successfully developed various graphitic like carbon nitride nanosheets by various precursors. We have characterized all the materials successfully. We have successfully applied this material for the separation of oil and water. We can apply this materials for the hydrogen energy production also. Another project is going on in my group. It is most efficient coating was graphitic like carbon when compared with another 0 dimension, 1 dimension and the inorganic nanomaterial. The separation efficiency of this coated mesh is nearly 75%. In the future work, we want to create the hydrophilic surface also. We have to try with more oil water saturation. As I told you, we are chemists. So we want to implement this technology for large scale. Therefore, now I am closely working with the chemical engineer to establish this process. Finally, I would like to acknowledge Advanced Materials in Science and Chemistry Conference organizers for given opportunity to deliver this lecture, and my research students and my collaborator from Qatar University, Majida Kaiser, Professor Majida. So myself and Professor Majida got this grant joint project, and we have successfully developed this methodology for the separation of oil. Still, some more research work is going on. to scale up the process. Thank you very much.
Yeah, thank you, sir, for your wonderful presentation on separation of oil from mixture. It was a very interesting talk. And there are some questions, just we'll have it first. And then I've got one question here, tried with steel mesh. So whether we can try with the aluminum as well as other mesh materials so that the cost will be reduced a little because steel is...
No, actually, if we use the other mesh, stainless steel is it is non-corrosive and it won't get any rust.
Okay.
If we use other mesh, there may be problem. We tried even copper and other thing.
I see. Okay, sir.
Hi, sir. This is Harish from GIT. I would like to know, sir, the heat resistant of that mesh, sir, which you created, whether it is stable at high temperature.
Yes, we have given the heat treatment until 120 degrees Celsius.
Yes.
To increase the robustness.
Okay, sir. Thank you, sir.
Yeah.
Any other questions?
Green chemistry is replacing our industrial chemistry with nature's recipe. Yeah.
Yes, please.
So I thank you for this informative session. I also thank you for being in this international conference. Thank you, sir.
Thank you very much. Again, thanks to all the audience and the professors, the scientists, those who have come from around the world and from your institute. Thanks a lot, sir. Okay.
Thank you very much, sir.
Thank you, sir.
Thank you.
Now I request S.V. Divekar, sir, to introduce Dr. Vaidyanathan Subramaniam, sir.
Ranga, sir, can you please stop your sharing, sir, presentation?
Okay, thank you.
Yes, thank you, sir. Ravi, sir? Hello, sir. Am I audible? Sir, are you able to hear me? Yes, sir.
So should I click on present now?
Yes, sir, sure, sir.
Are you able to see my presentation there?
Yes, sir. Sir, before we start, we'll have a brief introduction about you, sir. So give us 2 minutes. Thank you, sir.
Okay.
So I'm very happy to introduce Professor Vaidyanathan Subramaniam. He is Associate Professor of Chemical Engineering in the Chemical and Material Science Department of University of Nevada, Reno. Professor Subramaniam holds a PhD in Chemical Engineering from University of Notre Dame. He obtained his master's degree from University Institute of Chemical Technology, India. His research focus is on nanostructures materials for solar energy utilization. He has expertise in the synthesis, characterization, and applications of photoactive materials. In photovoltaics, clean fuel production, and environmental remediation. In his 12 years of research, he has developed inorganic materials, semiconductor, and semiconductor metal nanocomposites for application related to solar energy utilization and fuel cells. He has published more than 40 papers in reputed journals and guided 1 PhD and 3 MS students. He has received grant from funding agency to the tune of 1,41,000 $11,41,957 from various agencies in USA. He has developed, restructured many courses for chemical engineering and mentored postdoctoral researchers, visiting research scientists, and mentoring research professors at University of Illinois, Urbana. I present before you Professor Ravi Subramaniam, Vaidyanathan Subramaniam, Professor. So I request you, sir, so you present your talk. Yeah.
All right, thank you. Thank you so much. I appreciate it, and I hope your audience are able to hear, because I'm on the other side of the world, and then it's a little bit snowy out here in Reno, Nevada, so I may have some issues with my connection, so I apologize in advance if you're not able to hear me. Can you please let me know if my speed of conversation is it fast or slow?
So you are audible, sir, not a problem.
Okay, thank you very much.
Please go to your slideshow, sir.
I will go ahead and start with my presentation.
Sure, sir.
And just to make sure that my screens, are you able to see my second slide?
Yes, sir, yeah.
Okay, thank you. So the outline for this presentation is basically on...
Sir, can you go with slideshow option, please?
Excuse me?
A slideshow option. Full slide, sir.
Okay, can you see that?
Yeah, it's loading, sir, just a minute. So slideshow, I think it's not coming, sir, here. Full screen, sir. Yeah, there, yeah, down, just you can go with slide.
I'm sorry, I do not know how to...
Sir, at the bottom, can you see that 4 options, sir? Just before that volume, so there is one this thing's option, icon. Or else you can click.
I say present now. I'm going to present now. More options.
Sir, in the PPT, you have to go with full screen, sir.
In the PPT, I have to go with full screen.
So first you can go with present screen, then you can go back to your PPT and go with slideshow option, sir. So you can present your screen first.
Yeah, I went to present, then I've got your entire screen, a window, and a tab.
Yes, yes. You can click, go for that, sir. Click on.
So you want me to do your entire screen?
Yes, entire screen, sir. Yes.
Entire screen, okay. And then share.
Yeah. Click on share, sir.
It's not allowing me to click on the share.
So because a couple of minutes when you did it, actually we are able to see your screen, sir.
Yeah.
Yes, sir. Now it is getting presenting. Okay, so now we can go back to just a minute, I think. So, can you open just a PPT now? From the menu bar? Yeah.
Yes, I have done that. Open my PPT.
And there you can go with, no, we are unable to see your PPT, sir. So maybe you can rejoin the meet and once try again.
Yeah, I will do that.
Yes, sir.
I will just disconnect.
Yeah. Sir, can we play the?
Pull my presentation, please. Can you pull my presentation? I send my presentation.
Yeah, can I play that?
Yeah, please pull the presentation and then I will speak from here if you can toggle the presentation. I don't want to keep the audience waiting. Sorry about that.
Sir, actually you have sent the recorded video only, right? Can we play that?
Yes, you can.
Then at the end we can go for question session, sir.
Yeah, sure. Sorry about this.
Thank you.
Very sorry about it. Materials Engineering at the University of. Thank you for the introduction. My name is Ravi Subramanian, and I'm faculty of Chemical Engineering and Materials Engineering at the University of Nevada, Reno. It is a great pleasure for me to be able to give this presentation as a part of the Advanced Materials Science Chemistry Symposium. In this presentation, I will be talking of select inorganic oxides that are of interest in energy and environment. In this slide, I'm giving an outline of the key points that I will be discussing today. I will begin with what are the oxides, a general refresher on oxides list, and I will drive in the point about the multifunctionality of these oxides. Specifically, what are the types of these oxides and what are the properties? Then I will talk about titanium dioxide as a representative oxide. Many of you in this audience might have heard about this oxide in your research. I will specifically focus on the synthesis of one-dimensional titanium dioxide and some simple tools for characterizing these oxides. Then I will switch gears to talk about how these titanium dioxides can be used in two very prominent space of applications, that is energy and environment. Now let's look at oxides a little bit in general. Any oxygen-containing species are usually referred to as an oxide, and they exist in the gas, liquid, or solid phases. They demonstrate some unique features, such as serving as a raw material all the way up to a finished product. They mostly have got various types of application, and then they can be classified based on the type of application that they are used. This is mainly because of the fact that they demonstrate multifunctional behavior. Some of these oxides can also be used in more than one application because of their multifunctionality. They demonstrate interesting optical, electrical, electronic, catalytic, as well as thermochemical properties. They are known to have a wide range of applications, not just limited to energy and environment, but also in the space of health, industry, as well as space-based applications. Their properties can be improved by modifying them with a range of other material classes such as metals and non-metals. When we look at oxides, one of the common things that people do before determining which type of oxide to use is identify the various types first. In this slide, I have limited my discussion on the types of oxides based on their applications to energy and environment alone. If you were to narrow down the scope to energy and environment, you can classify the oxides as single metal oxides, multi-metal oxides. You can classify them in terms of their physical features, such as shape or geometry. Examples of this classification: rod, fibers, sponge, tubes. They can also be classified based on whether they are core-shell structures, something like a lemon, where the skin of the lemon can be considered as the shell, and the content inside the skin can be considered as core, or a coupled type of an oxide geometry. Now I'll talk about one specific type of oxide which has shown quite a bit of applications in the field of energy and environment, and that is called titanium dioxide. Titanium dioxide is a very well-known stable oxide of titanium and is often used using light as a driver or initiator of its process. Now, titanium dioxide is known and popular because of its multifunctionality, and it is known to have applications for all the spaces that I talked about. There's energy, environment, medical field, and other areas. In the space of environment, They are particularly known to use light and remediate toxic pollutants, both in the air as well as in water. In the energy space, keeping within the theme of light-driven reactions, they have been known to demonstrate splitting of water molecules to produce hydrogen. They have been used for photovoltaic applications, and they are also used for producing value-added chemicals. An example of a value-added chemical is hydrogen peroxide, where the commodity chemical, that means it is something that's used as a precursor for making a lot of specialty chemicals. While we have worked on these energy applications in my group, I will limit our presentation today to only photovoltaics within the energy space. They are also known in other related areas of applications such as high temperature processes, which involves steam reforming or partial oxidation, sometimes called as preferential oxidation of hydrocarbon to produce hydrogen. Titanium dioxide has also been used for different purposes as a promoter of water retention in polymer electrolyte fuel cell electrodes. Other we have talked and understood about the broad-ranging applications of titanium dioxide. Let's look at what is photocatalysis and what are the holy grail, what are the key things that one typically looks for when performing photocatalytic reactions. A photocatalytic reaction is defined as one where you shine some light on an active material such as titanium dioxide and it generates charged species. Charged species are called as electrons and holes. They are usually oppositely charged, negative and positive, and they are available for driving reduction and oxidation reactions depending upon what's in the surrounding of this oxide material. From the holy grail standpoint, there are a few points that one should keep in mind in order to make sure that the material that you are using for photocatalytic application is the right one. The first one among that is the material should remain stable in the presence of all the other things that's in the surroundings. That's often referred to as being corrosion resistant. It is expected that the material that acts as a photocatalyst is capable of absorbing light from the sun in an efficient manner, also commonly known as a visible light active material. Unfortunately, with titanium dioxide, we don't meet this requirement, the second bullet point requirement, because it absorbs only the UV part of the solar spectrum. There are ways in which we can combine the titanium dioxide with other materials to improve its absorptivity. It is expected that this oxide material demonstrates efficient separation of the charges, that is, the separation of electrons in the holes. It is also expected that the elements that form the building blocks of this oxide are inexpensive, abundant, and non-toxic to the environment. They are easy to synthesize, which means they are simple to process, cost-effective to process, and they are also scalable. And finally, it would be ideal if this material can be reused economically and meets all the goals of sustainability. Titanium dioxide is known largely and more popularly to be in the form of spherical particles. That's one of the most common ways in which this material is used. What then I'm introduced today in our discussion is the titanium dioxide in the form of tubes, hollow tubes. What you see in this picture is titanium dioxide in the form of spherical particles stacked randomly on the left-hand side And on the right-hand side, the titanium dioxide is in the form of nanotubes or small hollow tubes. The particles that you are seeing in an animated form moving from one location to the other are the electrons in this cartoon. The reason I'm showing these two pictures in the beginning is to illustrate the difference between the titanium dioxide in the form of nanoparticles and the titanium dioxide in the form of nanotubes. What is interesting to note in these two geometrical features is that the electrons in the first case, that is the nanoparticle case, tends to follow a rather irregular transport pathway, whereas the electrons in the nanotube seems to have a predictable and regular pathway. To understand this, I'm going to switch gear to something which is less scientific than the previous picture. And these two photographs that you are able to see, I would like for you to focus on the individual who is in the two-wheeler on this photograph and on this photograph. You might realize that this individual who is in this picture on the left will probably find it more difficult to go across than this individual in the two-wheeler in this situation. And this can be attributed to what we call as the orderly arrangement of these other cars. This individual struggles to go from this end to this end because of the disorderly arrangement of this other vehicles. I'm sure you'll appreciate that this analogy could perhaps help in better understanding of these two pictures. In this case, the electrons are having a very irregular pathway for their transport, whereas the electrons in this case travel much more orderly, which means they can, in this instance, this individual can go much more faster from one location to the other compared to this individual. So one of the biggest benefits of using nanotubes as opposed to nanoparticles is the possibility of being able to transport the electrons much more faster than in a nanoparticulate film. With this hypothesis, we now switch gear to talk about how to prepare the nanotubes, the synthesis protocol for preparing the nanotubes. You can use a process called as anodization or anodic oxidation. It is an electrochemical method that you can do in your laboratory using a very simple technique. It's basically a beaker with an ultrasonic bath, voltage power generator here, or DC power, and a voltage meter as an ammeter. You put the reagents in this, and I'm not going to go into the details of the reagents because the choice of reagents determine what properties you can get on the nanotubes. But with a cocktail of reagents here, which is basically an acidic bath, you can apply the DC power and the ultrasound simultaneously in order to grow the nanotubes by the process of anodic oxidation of the titanium. The mechanism of the nanotube formation is by the dissolution and reprecipitation of the titanium in the presence of these bath chemicals to form the oxides of a particular order. You can change the length, the thickness of the oxide walls, as well as the diameter of the nanotube by changing the DC voltage as well as the duration for which you are applying the DC voltage. Once you have prepared the nanotubes, you can treat it in a thermal condition at about 400 to 600 degrees centigrade in order to change its chemical properties. Here's an example of how this looks like. If you look at a titanium foil, you can see that there is a little bit of a darkness here as opposed to on the top. This point forward at the bottom is where the nanotubes are formed. And when you take it under a microscope, you can actually see that nanotubes have evolved in the form of hollow tubular architecture. They're all lined up and juxtaposed next to one another in a reasonably orderly fashion. If you take this nanotube and then thermally treat it, you can change the crystallinity of that oxide. Even after doing the anodic oxidation, you have some degree of crystallinity, but if you thermally treat it in an oxidative atmosphere anywhere between 400 to 600 degrees, you can form the oxides in the heated samples. The nature of the oxides can vary from anatase, rutile, or any other combinations thereof, and give you a very stable film. These features are also noted in nanoparticles as well as nanotubes. In our group, we have prepared these nanotubes on what I would like to call as a planar substrate or a foil, or in a wire, or in the form of a mesh, or in the form of a spring or a coil. It is possible to use the process of anodic oxidation to prepare these nanotubes on just about any physical geometry of the substrate. Now let's switch gear into the application of these nanotubes. One of the areas of key interest is pollution remediation, and particularly the one that is of interest to many people is how do we remediate the pollutants that are discharged in water. Examples of commonly known pollutants that are discharged in water is textile dyes. A popular approach is to take these dyes out of this water by taking carbon-based absorbents and putting it in landfills. There could be a better way to do this, and one of the common methods that has been used is photocatalytic degradation of these textile dyes using either a slurry-based titanium dioxide or titanium dioxide immobilized in films. What I'm going to talk about is how do we do this using one-dimensional hollow nanotubes. As an example of this application, I'm focusing on a class of dye called as azo dyes, which are known to be toxic and capable of mutations in the genes. And a specific example of this is methyl orange. You've got other types of dyes that are colored dyes like azo blue or Victoria blue or rhodamine dyes and things like that. All of these dyes have some of the other kind of problems in terms of chemical toxicity. The way we did it in our lab is we have taken a 3-arm electrode in which we have taken the dye solution and introduced the titanium dioxide nanotubes prepared in the form of a foil or in the form of wires. And we expose it to UV light after filtering it using copper sulfate solution. The reason we use a copper sulfate solution is to eliminate the far UV. The setup also allows us to apply a bias if we want to do an electrical signal on the side in order to manipulate the rate at which we are doing the degradation. This schematic shows how the setup in this 3-arm electrode looks like. It contains photocatalyst film where we are shining light, a reference electrode which is usually a calomel electrode, and then a counter electrode called as a cathode. So here is the result of our studies using the 3-arm electrode. This is the fractional conversion of the methyl orange dye along the y-axis and the time along the x-axis. You can see that if you take a nanotube of about 50 nanometer diameter, then about 50% of the dye is converted within a span of 3 hours. If you increase the diameter of that nanotube to 75 nanometers, then you can see that in the same 3-hour period, you have almost got complete conversion of the dye. Any further increase in the diameter does not have any significant bearing on the time aspect of the degradation. We went on further to use the Langmuir-Hinshelwood-Huijsen-Watson model kinetics study in order to fit in the rate parameters for this results. And if you're interested in how we do this, this is how we have narrowed down on the parameters that are to be optimized in the Langmuir-Hinshelwood model, and how we have used a lumped kinetic approach in order to find out the right constant. And what you can see is it follows a lumped kinetic model for the degradation of the dye. We also went further to demonstrate that the dye can be degraded using nanotubes prepared on wires. So this is the one where we have seen nanotubes on a foil. You can take the same nanotubes prepared on wires, and you can change the number of wires and perform the degradation. The idea of using wires is to ensure that light from all directions are captured by the nanotubes, as opposed to in this format, because if you're shining light, the other side is not exposed to light and it's no longer available for photocatalytic activity. Whereas that's not the case on this. Here, any refracted light can also be used for photodegradation. And it turns out that if you are taking a TiO2 foil, titanium dioxide foil, that is this configuration, then you are able to get a certain degree of degradation. Whereas if you take one TiO2 wire, 2 TiO2 wires, 3 and 4, you can see increased degradation. So this clearly tells us that if we are able to take the titanium dioxide nanotubes in the form of wire, we can increase the degradation rate much more than what it would be with just a foil. Switching to the last application, in this case the photovoltaics, we have studied the preliminary performance of TiO2 nanotubes for applications to solar electricity generation, which is what is photovoltaics. And again, we use the same system, that is the 3-arm electrode. Instead of using the dye solution, we use sodium hydroxide, because our goal is to find out how electrons are generated and how many of these electrons are there. We can count that. And the counting is done by observing what we call as the photocurrent as a function of time. So in this case, you can see that the nanotubes of 50 nanometers diameter are able to generate a stable photocurrent of about 0.4 milliamps. If you increase the diameter, you can increase the photocurrent to almost threefold, and it further goes up if you increase the diameter to 120 nanometers. So this tells you clearly that whether it is a photocatalytic application or photovoltaic application, we can leverage diameter to increase the responses of solar energy conversion. We also went on to assemble this TiO2 nanotubes as a part of a photocell, a rudimentary photocell, which is an anode and a cathode, and then an electrolyte in the middle. And in this particular instant, I'm just showing the results of TiO2 nanotubes produced on wires and sandwiched between two glass plates. So this is your wires. Actually, this is a mesh sandwiched between two glass plates. And the idea of using a mesh as the titanium dioxide substrate is to see if we can have any orientation and still generate electricity. So what we had done here is we changed the light to move and mimic the sunrise, noon time, as well as sunset. We did not put this photocell on a tracking device, and we could see that in any position, even without rotating this, if the photovoltaic panel is stable, which is usually the case in many situations, you put the photovoltaic panel oriented on a certain direction in the roof, you can see that the electricity generation is more or less the same. So we were able to show that TiO2 nanotubes produced on the foil or on the mesh is able to generate electricity in a stable manner. So to conclude, hopefully I have been able to get it across to you that oxides are multifunctional material with a lot of interesting properties. We can produce one type of an oxide called titanium dioxide in the form of tubes on just about any substrates like shown in that picture there. The nanotubes are dependent on the synthesis condition. As an example of that, I showed you that if you vary the diameter of the nanotubes, by changing the anodization voltage, you can change its physical properties. And by just changing the diameter, you have seen that it changes its application. We looked at two applications that are of popular interest. One is environmental remediation, and the second one is photovoltaics. In both these instances, the effect of change in the nanotube diameter has been shown to significantly help in improving the light utilization. This work was done by several of my past students who have been shown in this picture. It was also funded by federal agencies from the US federal government, as well as some of the funds that was provided in my university for both my research as well as for my undergraduate students, and as well as funds provided by my collaborators. I would like to thank you for your attention in listening to this presentation. I'd also like to thank particularly Dr. Ravi Raj for his kind invitation, for allowing me to make this presentation. I hope this was useful for you. If you have any questions, by all means, feel free to connect with me either through LinkedIn or through my email address at the university. Thank you very much.
Hello.
Yeah.
Can you hear me now, sir? Yeah.
First of all, I apologize to the audience extremely. I'm very sorry that this is, I never expected this going to be happening in this kind of I feel very embarrassed about this presentation. So I hope I get an opportunity to come and make it up for you guys when I come over there. Sorry about it.
No, it was very nice presentation recorded. This thing, we got everything very clearly, what exactly you're doing there and what is the research is going on. So it is about the inorganic oxides you spoke about. And then I've got one question connected to the anodizing of titanium, you said.
Sure.
Yeah. So the acids which you use, reagents, it depends on reagents you said, like oxidizing acids, chromic, sulfuric acid or anything out of that. So I think sulfuric acid is the best one for that, anodizing?
No, we have a combination of acids. Hydrogen fluoride, HF, is one of the most popular one that has been the one that has been used extensively. But then they have now come up with more of weaker acids, like you can do it with acetic acid, formic acid, or even nitric acid for that matter. We can also include ammonium salts in that mix that will allow you to pattern the nanotubes in a manner in which we can extend the orientations. Especially what I have not talked in this is you can change the surface features as well as increase the roughness, which will allow for the dye molecules to absorb, and also use it for the purpose of water splitting reactions, electrochemical reactions, or value-added chemical synthesis like hydrogen peroxide. Depending upon what is your chemical reaction that you want to perform, you can change the features by adding different materials to the mix.
Yeah, thank you very much. One more question I have. You said the anodizing process requires any surface preparation in the beginning?
Yes, the one that typically you do is you clean the surface of all the organic residues. So you can use acetones or alcohols in order to clean the surface so that you don't, and sometimes you can do a general abrasion using felt paper or something equivalent of that, because you can seed the nucleation of the process much more effectively and then increase the density of the tubes on the surface.
That means you mean to say create the roughness on the surface or smoothness?
Yes.
Yeah.
Yes, you increase the roughness on the surface, yes.
Okay. Thank you.
Hello, sir. This is Harish from GIT.
Yeah. Yes, Harish.
You told about TiO2 nanotubes. So have you used this for bulk sample degradation, means contaminants degradation?
We have looked at mixing various contaminants of different combinations. There is a work that was done in University of Patras, Greece. They have taken some pollutants which will allow you to generate hydrogen. So it is from waste to fuel. We have tried that one. We have also taken two different classes of pollutants. One is pharmaceutical waste and other is azodye waste. And you have to match them up because the redox potentials of these materials have to be appropriate in order to scavenge in order for the holes and the hydroxyl radicals to perform the reactions. Yes, we have done that. But it's not very successful. You won't get the kind of efficiencies that you saw with just one pollutant. You can get about 90% degradation in about 3 hours. You won't see that. It's more like 30 to 40% tops.
Okay, thank you, sir.
Yeah.
Have you characterized with XRD?
Yes, I just showed a few characterization results. We did XRD, SEM, PEM, XPS, as well as absorption spectroscopy, and even to some degree EPR.
Okay. What is the titanium oxidation state there?
Usually 3 plus to 4 plus. And you get a delta differential there depending upon what solvent you use for the synthesis of the oxides.
Okay. You have any picture with you now?
It's there in one of the papers. I don't have it in this presentation. I'm not able to. I'm so sorry. I'm not able to get it across through the media here.
No problem.
Sorry about that.
Okay, thank you very much.
Sure.
Thank you very much, Dr. Vaidyanathan Subramanian, and you have presented your paper early in the morning, 2 a.m. I think, now there.
It's just nearing midnight here.
Right.
Okay.
Oh, so it's really, we are very proud of you because we have done your presentation and interaction was very good actually in fact. So definitely we'll be in touch with you, sir, regarding anodizing of titanium, and we are more.
Yes, sir. I'm more than happy to help out.
Yeah.
There's a lot of students who are coming here, and I also visit. I will be there in India in 2 weeks' time.
Yeah.
And I'm more than happy to interface with anybody who might be interested in that.
Yeah, really, we will have interaction when you come to India. So just give us, send us one email so that definitely we'll have one session for you in Gokta Institute of Technology.
Absolutely. Thank you very much for your organization, sir. And I really appreciate the talks that has been organized as a part of the symposia. I learned quite a bit of all the research and then all the allied fields here. Appreciate the audience, and again, sorry about the technical issue.
Not at all. So your presentation was really good. So my interaction was equally good. So thank you very much. Yeah.
Thank you, sir. Yeah. Bye-bye.
Nanotechnology in medicine has a major impact on the survival of human race. So, I wholeheartedly thank you for the insights. I also thank you for being part of this presentation. Philanthropy is not about charity. It's about inventions and discoveries that have a broader impact, not only in the daily lives of the people, but also in the future of the nation. With this, I conclude today's invited sessions. On behalf of KLS Gokta Institute of Technology, I thank you all for being here and part of this international conference. Thank you. I request everyone to proceed for the lunch.
One more session we had actually, but because of the unavailability of the resource person, we could not arrange it. If possible, we may take it in the afternoon. So we are contacted already to him. So, but because of his unavailability or he has not responded, so we'll see if possible in the afternoon or tomorrow's session we can take his talk. Okay. And I request you all to take the lunch again in the same boys mess and come back to your rooms for the paper presentation exactly at 2:30. Thank you.
ಅದೇ ನಿಮ್ ಕಬಡ ಬರೋ ಇವನು ತೊಗೊಂಬರ್ಲಿ ಹಂಗೆ
ಸರ್ ರಿಪೀಟ್ ಆಗಿದ್ದು ಬೇಡ. ನೀನು ಯಾರಿಗೆ ಕೊಟ್ಟಿದ್ದು?
ಇವ್ರು ಎಷ್ಟಲ್ಲ
ನೀನು
ಕೊಟ್ಟಿದ್ದೀವಿ ಬೇಡ.
Dear participants, the participants from Malaysia, I hope I am audible to everyone. You can just put a message in the chat box. So we'll be now starting with the online oral presentation. Online participants from Malaysia, Abdul Samad Abubkar.
Yes, I am here.
Okay, Ubana is here. Ubana, Salihu, Ibrahim, Ashmita, Bilal. So we'll be having a presentation one by one, and already the timing for the presentation has been shared through email. So I'm going to repeat it once again. So it will be 8 minutes for presentation, and we'll be having 2 minutes discussion. And I request all the online participants to follow the time strictly. And you have received the mail today that before you start your presentation, you need to introduce yourself, and you need to highlight from to which category you belong, whether you belong to the UG category or PG or the research scholar or a faculty. Okay, with this introduction, you can start with your presentation. Abdul Samad Abubkar, can we start with your presentation?
Okay.
Okay, can share your screen.
Okay.
Over to Manvi.
Guys, can you see my screen?
Yes.
Yes, sir.
Okay. Okay, since you can see my screen, can I start?
Yes.
Okay. Thank you very much for organizing this. I would like to start with the existing protocol. My name is Abdul Samad Abubakar. I'm currently presenting from Nigeria. I'm a postgraduate PhD student under the supervision of Professor Dr. Muhammad Yunus Shakur from University Putra, Malaysia. My presentation today is about absorption of Kumasi beryllium blue G dye using bacterial biomass. And the co-authors of this research include Dr. Adila Yasid, Ahmad Razi Usman, and for Yunus Muhammad Shakur. This is the overview of my presentation. Background: the supply of azo dye accounts for 50% of the total global dye production, with 10 to 15% of dye waste being discharged into water bodies. Even in small amounts, these dyes are dangerous to the ecosystem and human health. And more concerning is that this dye pollution in Malaysia and many other places in the world
is aggravated by lack of treatment, and there is still high production demand for these dyes globally. There are a lot of conventional methods available, such as precipitation, flocculation, coagulation, reverse osmosis, ion exchange, membrane filtration, as it was discussed by some of the presenters in the morning sessions. But however, this conventional method, some of them have low efficiency, removal efficiency, and then high maintenance and production cost, and generation of potentially toxic byproducts. So in this study, we propose a low-cost and eco-friendly bioremediation alternative. We use bioadsorption. And some of the advantages of this bioadsorption include it can be used to treat both organic and inorganic pollutant. It is environmentally friendly. It has low cost, since the materials are usually available and then easy to culture, like in the case of microorganisms. The process is very rapid and a lot more other distinct advantages. In order to develop an effective and accurate model for dye removal, kinetics and isotherm studies is a very important study that it needs to be considered. So in this study, we need non-linear adsorption kinetic and isotherm models also. This slide shows the structure of the Kumasi Brilliant Blue G dye and also some of its characteristics. This slide shows some of the bacterial biomass that were previously used for the adsorption of dye. And this slide also shows the bibliometric assessment of literature on dye using microorganisms. In our methodology, we try to screen different bacterial biomass, and we check the effect of different parameters such as temperature, pH, adsorbent amount, their effect on the adsorption of Kumasi Brilliant Blue G dye. And we also use response surface methodology to optimize the adsorption. Kinetics and isotherm studies were also conducted. This is the slide shows the process of the extraction of the bacterial biomass for the adsorption. We screen 12 different bacterial isolates against the Kumasi Brilliant Blue G dye, and then isolate 52 has the highest adsorption capacity. And this isolate, it was previously isolated from a previous, characterized and identified from a previous study as pseudomonas species strain NL02. This slide shows the effect of one factor at a time. That is the parameters we try to check: the effect of time, dye concentration, pH, agitation speed, adsorbent size, and then temperature. So this is the summary of the optimum conditions for the one factor at a time optimization. The contact time was 60 minutes, dye concentration was found to be 30 milligram per liter, pH 7, agitation speed 120, adsorbent amount 0.66 gram, temperature 40, dye removal percentage was 70, and adsorption amount in milligram per gram was 6.3. After the one factor at a time, we try to optimize these factors using response surface methodology. The placard Barman design was used to screen these factors that were previously used in the OFAT, and then this is the ANOVA for the PBD design. We use software, a design expert to conduct the RSM optimization. The ANOVA shows that the p-value, the model is significant, lack of fit, and adjusted R square was close to 1, and the significant parameters were dye concentration, temperature, and contact time. After the PBD, we try to use central composite design to also optimize the most significant factors. And then the PBD design give experimental value, a predicted value, and then we conducted the experiment and we compare the predicted levels and the experimental levels. And the highest absorption for the experimental value was 79.17, and then for the predicted level was 81.02%. This is the ANOVA for the central composite design, and the model was significant, lack of it not significant, and the adjusted R square was close to 1. And this shows the 3D surface plot for the absorption of the Kumasi beryllium blue G dye showing the significant factors. This is the experiments was validated based on the predicted levels, and then it shows that the response, the absorption was between the predicted and the experimental level, there was no significant difference. This shows the absorption profile for the kinetics model, where it shows that the dye follows pseudo first order kinetic model based on the curve fitting. And this table shows the calculated maximum absorption capacity of the selected models as pseudo first order kinetics. And then isotherms, the kinetic studies, like I said, shows that the pseudo first order, the absorption follows pseudo first order kinetics with the lowest ICC value and then adjusted R square. This shows the fittings of different concentration for the first pseudo order kinetic model. And the equilibrium isotherm model for the dye, this graph shows different fittings for the different models, and it shows that the tooth model was the most suitable model. This slide shows the absorption model parameters for the isotherms. These are the different isotherms models, and then these are their parameters. Like I said, the tooth model was best fitted based on the adjusted R square and the lowest AICC value. In conclusion, different bacterial isolates were screened against Kumasi beryllium blue G dye, and the pseudonomous species from MN02 biomass was found to have a higher percentage dye removal of up to 41%, and OFAT and RSM was used to improve the dye percentage removal 69 and 87% respectively. The adsorption was found to follow first pseudo-order reaction, and then statistical analysis using corrected AICC's root RMSE, adjusted coefficient of determination AF and BF, that shows that the tooth model was the best isotherm model for the adsorption of Kumasi beryllium blue G dye. And above findings shows that a potential use of bacterial biomass pseudonomous species from MN02 as an effective bioadsorbent. Some of the recommendations: a field experiment inside natural dye location should be conducted to establish the competence of this strain in response to environmental conditions. Future research will investigate the multi-absorptions, since real-world dye effluent often contain a variety of contaminants, e.g. heavy metals. Bacterial biomass consortium studies is also recommended. It is also recommended that future research should be conducted on the recycling of the biomass after absorption, These are a list of my references. Thank you for your audience.
Hello. Hello, Mr. Abubakar.
Hello, yes.
You can hear me, no?
Yes.
Yeah, okay, very nice presentation. Just one or two questions, quick questions. This biomass, once it is absorbs all the dye, how do you remove the dye from that one?
Yes, that's why this is a part of my PhD work, and then there are other parts, and then that's why in my recommendation I said that future studies should also consider how this biomass can be recycled after the adsorption.
Yeah, correct. You said it in conclusion, but what is your mind? How do you remove that one? Is it possible to remove all 100% dye? Can you remove all 100? Yeah. Yes?
But then you say, is it possible to remove all 100% dye?
Yeah. No, from the biomass. From the biomass.
From the biomass.
Yeah.
Yes, there are some there are some this thing that proposes using this biomass as biochar.
Okay, 1 minute, one more. Did you try with any other method to degrade that dye? And then you can compare your biomass is better than other method. Did you do that one?
The degradation aspect, this study give more emphasis on the adsorption, because there were some other research team that they are working on degradation and then decolorization. There are different things, and there are, in some cases these dyes are very recalcitrant, and when you try to degrade them, the smaller compounds, they are even more toxic than the main parent compounds. So that is why this study is focusing on adsorption.
Agreed.
Because some of the
Agreed. Very good. Nice. Okay. Thank you very much. Yeah, good. Anybody? Hello? Yeah. Please listen to another question.
Okay.
Yeah, one simple question I want to ask you. You said biomass you are using for removing azo dyes. Okay. Yeah.
Yes.
Yeah, what about the quantity of biomass which you can produce? Because the quantity of water which gets polluted with the azo dyes, it is too much.
Yeah, it's too much. Like I said in my recommendation, this is a laboratory scale experiment, and then it should be considered in the real world. And is the one thing that is very interesting about this bacterial biomass is it's easy to reproduce, but I know generating large quantities could be tedious, and it involves a lot of maybe.
Yeah, because multiplication of the bacteria, again, you require some nutrients so that finally it grows and then biomass is generated, which consumes a lot of energy again, means resources are required. Correct?
Yes, but they are very easily, they don't require much nutrients. And you you can only use nutrient broth.
Okay.
To grow them.
Yeah. Fine. Nice.
Thank you.
Yeah.
For the next up, I would call Ubana Mohammed Abdullahi. Can you hear me?
Yes.
Okay, can start with your presentation, sir.
Thank you. I want to share my screen.
You can share your screen, sir.
Okay. So, can I share my screen? I can't find the icon for sharing my slides.
Present now.
You can present it now. Present now. It's the arrow mark is given there down.
Besides smiley option.
Aroma.
Beside the smiley option.
Okay.
Sixth icon from left side.
No. Baca. Tapi di slide kira ini. Orang lain juga. Orang suka. Ini. Itu nanti kita kan mana slide. Can you see my slide?
No, sir.
Sir, in the Google Meet, so there is one icon which is on the 6th place from the left side. Yeah, it's getting now, yeah. Right. So, yeah, we can go with the slideshow, please.
Okay, can you see my slide now?
Yeah, it's visible.
Okay.
Click on slideshow, please, in the PowerPoint. So that we can go with full screen.
Okay.
Yeah, perfect. Yes, you can proceed now.
Okay. Good afternoon. I'm Mohammed Abdullahi, postgraduate students from Basic Data. I'm presenting on sustainable bacterial biomass, petroleum remediation through disruption. My contents are background, groups like global treatment, materials and method, result quantification, references. Now, as a result of industrial activities, such as electroplating, metal finishing, metal tanning, wastewater containing high concentration of metal hexavalent chromium are released into the ecosystem. Now, this hexavalent chromium is toxic to human, thereby exerting detrimental effect to humans, such as headache, nausea, diarrhea, leading to carcinogen, cancer. Hello?
Yes, sir.
Okay. Now, several efforts have been made in order to remove this toxic contaminant. Now, the methods used for the removal are biomass in order to reduce the concentration in the environment. Now, other conventional methods have been used in order to remove these heavy metals from water. Some of these methods are physicochemical and biological methods. Under the physicochemical, we have the coagulation, electrocoagulation, chemical precipitation, oxidation, ion exchange, irradiation, membrane filtration, adsorption. While under the biological methods, there is a treatment by bacteria, treatment by fungi and yeast, and then treatment by fungi and by algae. Now, by second is the biological removal of plants from bodies of water, especially metals which are not biodegradable. Now, this is a clear scheme as to how bacteria, different mechanism of how bacteria absorbs contaminants. Now, among the mechanism, there is the metal-microbe interaction, biomineralization, enzyme, catalyzed, we have the biolysate, then the methods I'm applying is the bioabsorption. Now, materials and methods. These are chemicals and equipment that we are used for the research. Among the chemical, potassium hydrochloric acid, sodium hydroxide, 1,5-nitramazide, the distilled water, butane, agar, and broth. Then all other chemicals were used under analytical gradient. Then I also use autoclave and the UV spectrophometer. Now, for the preparation of chromium solution, the stock solution of 500 ppm chromium was obtained by dissolving this in distilled water. Now, the standard solution of chromium was prepared in a stock solution, and the pH was adjusted using sodium hydroxide and then sulfuric acid. Now, this is the method that was used in biomass, in the harvest of biomass. Now, the contaminant was gotten from the contaminated site. Thereby, no one they are being inoculated on the nutrient area. After it is being grown on the nutrient area, the isolate is thereafter inoculated into nutrient blocks. And at this point, the nutrient block is allowed to stay for about 24 hours under a shaker, thereby agitating in order to harvest the microorganism. Now, after this, the sample is then centrifuged, in order to separate the supernatant and the pellets. Now, two methods are usually applied in terms of final harvest of the biomass. Now, after centrifugation, the supernatant are discarded, then the pellet is being dried inside the oven. While that is for the dry, that is in terms of harvest for the dried sample. While for the wet sample, the wet sample is thereby diluted into distilled water and then used for subsequent studies. Now, after that, I decided to check for the percentage absorption percentage of the different isolates. Now, I discovered that out of the 7 isolates I screened in order to check for the absorption capacity, I discovered that UB1A tend to have high absorption capacity. And so as such, I decided to use it for further studies in order to check for the effects at different time. That is under checking the concentration at different time interval. Now, based on the experimental results, it shows that at 100 minutes, it shows at the point where the biomass tend to absorb the common position. Thereafter, I now decided to transform this into kinetic model. Now, the kinetic models of the absorption is thereby applied into 2 models. That is applied to first CDO order and then second CDO order. Now, from the analysis, it shows that it splits into both first and second order. Now, the experimental data obtained by running the contact time using, that is against QT, which is really
Your time is up, so you can go with your conclusion.
Okay. Now, from the conclusion, considering the experimental result obtained, metal uptake was most efficient at contact time, biomass dosage, validation speed of 100 minutes, 0.1 gram, and then 100 ppm was. Now, the optimal dissection capacity under this condition was 2.574 milligram per gram. The results also indicate that it fits into both model, that is first and second model, which implies that they obey physio and chemoabsorption mechanism. This are my reference. Thank you.
Hello. Your wastewater contains only chromium or some other elements also?
Sir?
Your wastewater contains only chromium or any other elements?
No, only chromium.
Only chromium. Oh. Suppose if there are mixture of some different elements there, what would have been your result?
No, what I mean is, the chromium I mix potassium bromate with distilled water.
Okay, how the chromium gets interacted with the biomass?
Okay, through the cell wall of the biomass.
The biomass is made of which, what material?
Bacteria, sir.
Yeah?
Bacteria.
What is the source for biomass?
Okay, the source of the biomass, I got it from contaminated sites, sir.
Hello? Yeah?
Hello?
Yeah. So chromium you could remove almost 100%?
No, not 100%, sir. But we're able to remove the contaminant 100%.
Okay. If you want to improve the removal to 100%, what is needed? How much you have removed? 60%?
No, what I was able to achieve was about 40%. It was when after I screened the microorganisms. So I discovered that one of the microorganisms was able to bioabsorb the chromium.
Are there any other methods for removal of chromium from wastewater? Are there any other method to remove chromium from wastewater? Have you tried it?
Yeah, yes, sir. There are other methods, as I earlier said.
Did you try?
Physical method, sir.
Did you try?
No, sir, I did not try that.
Okay. Hold on.
You said biomass you can remove chromium 40%, up to 40%. Now what's the contact time? How many hours you kept that for shaking?
I kept it for about 100 minutes.
100 minutes,
Yes.
1.5 hour almost. Huh?
Yes, almost 100 minutes.
Okay. Now, one more question connected to the, you said biomass after generating, you have dried it at particular temperature, that figure was indicating. What's the drying temperature?
Okay, at 60 degrees Celsius.
60 degrees. Okay, fine.
Next up, I call upon Shahi Yahuza. Are you there?
Hello, can you hear me?
Yes, you can hear you. You can go with the
I'm
presentation.
trying to connect with the system that I can share because I joined with my phone, so I'm trying to connect with the system.
Okay, sir.
Alright, now you don't have any other sabon.
Just 2 minutes, so sorry, just 2 minutes. Hello?
Yes.
I said just please 2 minutes. I'm trying to connect with the
Okay, sir, no problem.
Wait a minute, they were getting
Mr. Obama, can you mute yourself?
Okay.
Yes, I'm connected.
Okay, sir. Mr. Ubana, can you please stop your presentation also?
Hello, can you hear me?
Yes, we can hear you.
Okay, now I can share. Please, I want to share. How can I do that?
You can go to sixth icon from left side beside the smiling emoji.
6, yes, I am on it.
The arrow icon.
Yes, I can see I am on it. I click on it, but it's displayed that select window or screen.
Select the window and share the entire screen. And click on the screen and there will be a share option.
When I click on it, on the 6th icon, it displays your entire screen and a window. So which one is the right one?
Click on the screen and then share it.
Your entire screen, right?
Yes, sir.
I clicked on it.
But
Okay, I have to open the slide, right?
yes, you have to open the slide. But it's not getting shared, sir. Click on the 6th icon once again and then share the entire screen. Click on the
Can you see
entire
it?
screen. And then
Can you see it?
No, sir, no, we cannot see it. Then when you go, you should click on the small icon and then you will get the share option.
Okay. Can you?
Yes, sir, we are getting.
I'm sharing.
Yes, sir, it's visible. Can you open
you
your
see it?
PPT?
Can you see it?
Yes, sir, we can see your screen, but not your PPT. You should open your PPT, please.
Okay. I put it on slideshow. What's up now? Can you see it?
Yes, sir, we can see it.
Okay. Good afternoon.
Sir, but we cannot see your PPT. Your PowerPoint presentation.
I open it.
I'm sorry, sir, but it's not visible. Just minimize your Google Meet screen.
Okay. I minimize it.
No, sir, still we are unable to see it. So it's not minimized yet.
But it said, okay, maybe it's from the window, it's from the browser. I'm using Mozilla. Because it has shown that I am presenting.
No, sir, don't stop the presentation. Just go to the this thing, your presentation, PPT. Go to your PowerPoint. Your screen is visible, but not your presentation. Minimize the whole screen.
Okay. I minimize it.
Okay, but it's a black screen, sir.
Okay, now I'm opening the PowerPoint. Can you see it?
No, sir, we cannot.
Can you see it now?
No. Okay. So you can stop the presentation and then start it again.
Okay. We'll open it now.
Okay, sir. So it's visible?
Can you see it?
Yes, sir. You can go with
Can
the
you see it
slide
now?
show. Yes, sir. You can start your presentation.
Sorry for the delay.
Okay, so no problem. Thank you.
Okay.
Okay, just be relaxed and start your presentation. Thank you.
Okay, I'm presenting on equilibrium kinetics and thermodynamic studies of the biassumption of reactive rate 120 dye by the biomass of Enterobacter species strain MM05.
So can you introduce yourself as your UG student or PG student or a staff member?
Hello?
Hello, sir. Can you introduce yourself as you are an UG student, PG student, or a...
Okay, so sorry for that. I am Salih Yehuza, a PhD student at University Putra, Malaysia. I am currently in Nigeria.
Okay, sir.
So I am presenting on the topic equilibrium kinetics and kinetic and thermodynamic studies of the biassumption of reactive rate 120 dye using the biomass of Enterobacter sp citron MM05. Based on this content, introduction, problem statement, significance of the study, research hypothesis, aim and objective, material and method results, and discussion, and finally conclusion. So textile dyes, textile, paper, paint, printing, and cosmetic industry discharge a huge amount of wastewater containing synthetic dyes. So most of these dyes are poisonous, carcinogenic, teratogenic, and can cause allergic dermatitis, that is skin infection and pigmentation. They also impart color to wastewater streams, thereby preventing the sunlight penetration. So it affects and that affects the process of photosynthesis. Biassumption is a physicochemical process that include mechanisms like adsorption, ion exchange, surface composition, and precipitation. So it is an attribute exhibited by both living and non-living biomass. It is estimated that the textile and manufacturing industry use more than 10,000 commercially available dye. It was a textile industry that consumes about 1,000 tons of the dye per year, and approximately 10 to 15% of this dye being discharged into streams as effluents during the dyeing process. The physical and chemical procedure are utilized to remove dye. Despite the fact that physical and chemical procedure are utilized to remove dye, alternative approaches like biological systems refer to drawbacks such as high cost, limited application of dye types, and large-scale dumping of sludge. In recent years, research has focused on the existence of organisms that are capable of removing various types of dyes from wastewater. Microorganisms like bacteria, fungi, and algae have been reported in so many researches to be used as biosolvent in the process of biosolution of different dyes. In recent years, commercial biosolvents were developed by companies for biosolution of metal ions, like advanced mineral technologies that is based in Idaho, use a new biosolvent, AMT BioClaim, that is made up of bacteria from the genus Bacillus for dilute wastewater treatment and metal recovery. Biorecovery systems are based in Las Cruz, USA, produce algal salt, that is an algal biosolvent that is made by immobilizing Chlorella vulgaris. This Chlorella vulgaris is a green algae species on a silica gel of polymer matrix. So the problem statement, generally speaking, dyes have negative aesthetic effect on the wastewater, and some of them are thereby degraded coated are toxic, mutagenic, and carcinogenic. Synthetic dyes not only affect the aesthetic quality of water source due to their color, but also increase the biological oxygen demand and chemical oxygen demand, inhibiting the rate of photosynthesis and plant growth. Each year, million tons of dyes are produced globally. Wastewater containing dyes, when discharged to water bodies and water treatment plants, affect the ecosystem, thereby posing a serious health problem for flora and fauna and requires humans. Today, it has become crystal clear that dyes cause negative effect in all ecosystems, and that the active management dye is of particular concern to our health. Justification of the study. Dyes are such an important compound that withstand biodegradation and therefore require an alternative means for their removal from wastewater. This is because they are recalcitrant, they are non-biodegradable. Several researches have been carried out for the removal of dyes from wastewater, and suction method is considered to be preferable. Suction method in this regard, biological method. Researchers have employed physical, chemical, and biological method in dye suction. Among the suction method, biological method is proven to be widely used because of its ease, cheaper, and eco-friendly.
Are you there, sir? Hello, am I audible?
Yes, we can hear you, Salu.
Yes, sir, I can hear you now. No, he's not there, I think. Yeah, message. Yeah, there's a lot of network issue back then.
Yeah, you tell him that, this will give him a chance. If he is able to receive your message.
He's not responding back, sir.
Yeah, he is not responding. The message is going.
Message.
Is that much and you can ask the next person. You did it.
Internet issue is down. Mathematical improvement for good. Okay. It's not there. It's not there.
There is a network issue from Mr. Yahuza's side, so I call upon Ibrahim Sabo to present the next one. Mr. Sabo, are you there?
I'm here. I'm here.
Okay, so you can start your presentation. Yes. You can start your presentation, Mr. Sabu. Are you, can you hear me, Mr. Sabu?
I'm trying to share the screen.
Okay, yes, sir. We are able to see your screen, sir. Can you please share the PPT?
You said?
So we can see your screen. Can you share your PPT, PowerPoint presentation?
I'm trying to share.
Okay, it's gone now, sir. Actually, we were able to see your screen. So it's down. You can open the PPT. Below, down.
Can you see the screen now?
Yes, sir. We can see your screen, but not your PowerPoint presentation. It's below there.
Can you see it now?
No, sir. So you need to open your PowerPoint, then the screen.
Okay.
Once you first tell them first open the pop and then share the screen.
So first open your PowerPoint, then share the screen.
Same.
Can you see it now?
No, sir, we are unable to see it. So can you open your presentation first, open your PowerPoint presentation, then share your screen.
Okay. I opened it already.
So first stop your presentation, stop the screen
Can you see it
presentation.
now?
No, sir, we are unable to see it. So minimize the screen and then open your PowerPoint presentation.
Okay.
Half minimize.
Can you see it now?
No, sir. So don't share your window, you should share your entire screen.
Okay.
I think you need to stop sharing and reshare again.
Okay.
Stop sharing and then reshare again.
Okay.
So first minimize your screen, then open the PPT. Go to your desktop or somewhere you have shared it.
Can you see it now?
No, sir. So you have not yet presented. Go to the sixth icon and then click the share the entire screen, not the window.
Okay. I already do. Hmm?
Yes, so we can see the screen. Now, can you please start the slideshow and then your presentation?
Can you see it now?
Yes, sir, we can see it.
You can see it now.
Can you please start your...
Okay. My name is Ibrahim Alaji Sabo. I'm a PhD.
Sir, can you share the slideshow?
I'm going to present on the topic, the behavioral kinetics and thermodynamic study of the dissolvation of Pongored dye by the biomass of Serratia substance strain. The content of the presentation. My presentation will be based on this quantum introduction statement of research program, research hypothesis, on an objective methodology, result and expression, and conclusion. In background, there are important compounds that are widely employed in a variety of industries, including paper printing, laser, and plastic companies. That can easily cause an infection disease
among other environmental pollution, dye has also been considered to be pollutant. And the presence of dye, even in small amount, cause a hostile environmental impact due to their carcinogenic nature. Dye can also affect aquatic life as it affects photosynthesis. It can also interfere with gases in the water body by interfering with the penetration of sunlight into the aquatic environment. Many pharmaceutical products are meant to cure diseases caused by pollution. It's a need to remove pollution and to minimize burden on pharmaceutical industry. Textile industry use dye to color their products, and dye have been considered as a hazardous pollutant by various major environmental agencies, including the United States Environmental Protection. The presence of dye in water can cause hostile effects. Government statement. The most common pollutant removal management technology chemical like coagulation, flocculation, precipitation, incineration, electrochemical oxidation, osmotic ion exchange, sedimentation and ozonation method, etc. However, some of the above methods or techniques have been proven to be insufficient and expensive. And they can also generate or release a potentially toxic byproduct into the environment. They are also too slow to complete. Therefore, bioreduction is the most effective and versatile method or technique for removing wastewater and have several advantages. As it is highly efficient and cost effective, it can also minimize chemical or biological risk. It also has a low operational cost, and it is environmental friendly and does not put in the formation of any harmful substances or compound. Hypothesis: the bacterial biomass can effectively remove dye in an aqueous solution using cost-effective techniques. The application of RSM, as stated in the literature, has greatly enhanced absorption over the traditional upward approach. It is also believed that a similar result will be obtained in this research. The absorption rate can also be modeled using gross kinetic, isotherm, and thermodynamic model. The aim of an objective. The aim of this research is based on to screen and optimize the absorption condition of conglomerate dye using one factor at a time and response surface methodology. Number two, to screen to characterize the bacterial biomass using FTIR and SEM. Number three, to determine kinetic and equilibrium model for conglomerate dye bioabsorption. And lastly, to study thermodynamics of conglomerate dye bioabsorption through non-linear and Bonhoeffer. Use some of the literature of the kinetic and isotope model from various bacteria discussed using different dyes. And this is the thermodynamic parameter of different dyes using different microbial biomass from the previous literature. The methodology. This research, the methodology of this research is as follows. There is a screening, then followed by the optimization using upward RSL, then biomass characterization using FTIR and SEM, then a kinetic model, isotherm model, and thermodynamics. For the screening, a volume of 10 of conglomerate was mixed with a 0.9 of each of the 12 inactivated bacterial biomass of the biomass. The plants were labeled appropriately and incubated at 25 degrees centigrade and 150 RML. And this, the absorbents were measured using a spectrophotometer at 507 nanometer. That is the absorbent to which the results were measured, were recorded. Then for the optimization is divided into two. We have upwards and we have RFR. For the upwards, the absorption of that is affected by a wide variety of parameters. The upward method was employed to optimize the condition for the conglomerate dye using isolate that is the Sarasha maximum MM06. Optimization conditions such as initial dye concentration, contact time, pH, agitation, speed, and temperature and the absorbent side was done and one after the other. The optimization is done one after the other, in which the previously optimized parameter kept constant. Then for the ISM, following the software recommendation, that is the time expert, that is the name of the software used to optimize using RSM. So following this following drop-in to screen 6A dependent variable, that is a initial dye concentration, contact time, temperature, absorption size, pH, and this these parameters already been predicted using the PDA, using PDA, and the software was used to do an analysis of bias, that is ANOVA. Then the parameters were further optimized using three-level factorial, where pH and absorbent size as the most significant parameters. Then for the FTIR, that is biomass characterization, based on biomass characterization, I characterize into FTIR and SEM. The biomass for FTIR, the biomass is harvested and mixed with dye, and incubation routine is followed. The mixture was dry using an oven at temperature of 60 degrees centigrade. The dry nature of the dye and the biomass was sent for both FTIF and SEM analysis. Then for the kinetic modeling, a batch kinetic experiment was performed at various dye concentration based on the result obtained from the OPAT and ISM. Following the incubation period, the supernatant was used, the supernatant was then analyzed using a spectrophotometer at a 507 nanometer, that is the wavelength, at various time intervals. The absorption were measured, recorded, and a graph was plotted. For the absorption, that is for the absorption isotope, which is carried out by fitting the equilibrium data at various isotope models. That is using the model using long for glitch bed plot. See, this study, a batch absorption experiment were conducted at a different temperature of 25, 30, 35, 40, and 45 to evaluate the influence of temperature on congruent dye absorption. And this is the result for this. And based on the screening, 12 isolates were used, and it was shown that isolate 34 SR, which is a Sarasha which is Sarasha, has the highest absorber. And this is the standard template on the data control. And if you look at it, the graph is a uniform, it's linear up to 90%, up to 90%. And this is a result for the initial dye concentration. And this is the result for the contact time, where 20 minutes is the most optimum time. And this is the result for the pH, where pH of 7 is the optimum. And this is the result for the agitation, where the 125 ppm is the optimum. And this is the result of the temperature. And this is the result of the
Your time is up. Can you go with the conclusion?
Okay. And okay. And this is the result for for the optimization using a software that is using a PDA system. This is a 3D comparison of the result. And this is the result for the FTIM. This is a control, and this is a control, and this is at a 30 milligram per minute, and this is at a 90, and this is the comparison of the FTIM control. This is also the result of, this is the peak, the result of the peak functional group of 10. And this is the result of the cell, that is before and after the absorption. And this is also the analysis of the elemental analysis after the absorption, before and after the absorption. Then this is the kinetic result. And this is statistical analysis of congruent absorption using kinetic model, which show that a single second order is a base model. If you consider the AICC value, this is the graph of the model using a curve expert, and this is a determination of this isotope model. This is the result of the isotope, and based on the result, it is indicated that Langmuir is against a isotope model, and this is a graph of the model. For the thermodynamic study, this is a graph of the.
So your time is up.
And this is the parameter.
Conclude it, please.
And in conclusion, right now we are concluded we are conducted in triplicate, and the data were analyzed by one-way analysis of Marian status ANOVA with p-value 0.05 indicating statistical significance. The result also shows an increase in absorption capacity using optimization, equilibrium, absorption pattern, following and kinetic. And the thermodynamic results show that the reaction is continuous and is also endothermic. And based on this finding, it showed that congruent dye can be used to remove a wastewater, to remove a parasha can be used to remove a wastewater, using to remove a wastewater. This is the references. Thank you.
Okay, Ibrahim, you just tell me this target solution, that Congo Red, is it lab-made wastewater, or you have taken from the actual wastewater?
You said?
Is it an actual wastewater, or you have prepared that wastewater at laboratory?
This wastewater we prepared from the laboratory.
Laboratory, okay. And
yes,
supposing if Congo Red as well as one more dye is present in that one, then what will be the efficiency of your biomass to remove only Congo Red?
It's sir.
If there is one more dye in the solution, if one more
that's only screening, sir.
Okay, you are starting with Congo Red, fine. Supposing there are
we screen about 12 different bacterial isolates, and based on this screening, sir, there are other bacteria that can be used to remove a Congo Red dye. But based on this screening, using this 12 bacteria isolate, this bacteria Serratia show a higher percentage removal of this Congo Red dye. So that's why I choose to use this bacteria.
Okay. Fine. Thank you. Yeah.
Thank you.
Thank you. Next we have Miss Tashmita. Are you there?
Hello, can you hear me? Hello?
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 Can you hear me? Yes.
Hello, Mr. Shahuza.
No. Yes, I don't know my stand.
So can you give it at the last, at the end?
You say?
Hello?
Ma? Hello, can you hear me? Yeah, ma.
Hello, Mr. Shahiu? Can you hear me?
Salihu, yes.
Yes, sir.
I can hear you.
So, okay. So you can present it now. The remaining part.
Present it now. Okay. Can I show the
Yes, you can stop your presentation, sir.
Okay.
And you can go ahead with the remaining part, Mr. Yahuza.
Okay, let me quickly, because I have no charts, but let me quickly present it.
Mr. Abdullahi.
Yes, sir.
Okay, unmute yourself, please.
Okay.
Answer.
Wait.
But they're not presenting, they're trying to do their own.
They have not prepared it.
It's already 1.5 hour now. 2:30.
Hello?
Hello, sir.
Sorry, okay, someone can prevent maybe not because I have looked at the system is on.
We can't hear you clearly, sir, and we cannot see your screen too.
Yes, it was my computer, no chat on the computer.
Okay, sir. We'll give you a chance at the end. Now we'll continue with Miss Tashmita. Miss Tashmita, are you there?
Yeah, I'm here. You have question asked me?
Hello, would you start your presentation?
Yeah, I'm sharing my screen.
Do it.
How will it go now?
Don't do it.
Yes,
Shahpur. The problem is I don't have button from here to the local.
You have to then go as then we from there.
Yeah.
This what?
No, 520. I don't. Yeah, 520.
Also same time.
Yesterday it was all over.
Only 6 people there is offline. 6 people
Hello, Miss Tashmita, are you there? Miss Tashmita?
Yeah, I'm sharing the screen.
Would you please share your screen?
Yeah, I'm sharing now.
Should I? It's so easy.
not used to with technical then all not used to. So then they kind of screen, we have to share screen.
Videos are there.
Then they know
Yes, Ms. Tashmita, you can go with your slideshow. We are able to see your presentation. Can you please introduce yourself?
Okay. So can everyone see my slide?
Yes, yes, we can see your screen.
Okay. Okay. Hi everyone. My name is Ashwita Nebusparayan. I'm an undergraduate student from University of Malaysia. The title of my project is a low-cost local source of acid residue for pesticide detection in sensing growth. Okay, basically, there is two main pesticides, which is organic phosphate and carbamate usage is a biggest concern due to neurotoxicity properties of this compound. But then we can't run away from using pesticide because it helps in crop protection by controlling the pests in agriculture. Okay, next slide. As you can see in figure 1, plastic cholesterase is actually a key nervous system enzyme which will break down the neuroplastic plastic colony into chloride and acetate. But whenever there is a presence of pesticides, for instance, organophosphate, when it binds the active side of the enzyme, it will prevent the breakdown of the acetylcholine neurotransmitter. So what happens is the acetylcholine will just accumulates, it will cause a distortion in the neurotransmission. Okay. So since acetylcholinesterase enzyme can be easily inhibited by this pesticide, therefore we have acetylcholinesterase from fruit fly and bee brain organs to be a very quick, sensitive, and low-cost screening of pesticide from fruits and vegetables. Even acetylcholinesterase from red tilapia or even like catfish has been demonstrated to be susceptible to pesticides at sub ppm level. But then, when we're using acetylcholinesterase as a source of enzyme monitoring purposes, we have to look at the stability studies, like what is the best temperature to store the enzyme and what will be the sensitivity of the enzyme after we perform partial purification. So, the problem statement, this is not something very new. We do have a commercial source of acetylcholinesterase from electrophorus electricus, but it is very expensive. To know the cost, we are going to use local sources for detection purposes. But then the sensitivity of the local cost towards pesticide and of course the stability during the COVID, that must be studied because it will be it's actually expected to be different from the commercial stuff that we have today. So the hypothesis will be, we're going to perform a partial purification using amino sulfate fractionation, which is expected to improve the enzyme purity and storage stability. And also, once we partially purify the enzyme from the catfish, it's expected to be more sensitive towards the pesticide. Objective of this research will be to partially purify the enzyme from the fish using amino fractionation, and also to study the enzyme stability of the food and amount of its suspension at different storage temperature for 1 month. And we also want to find what is the concentration of the pesticide that causes 50% inhibition in enzyme activity for both the crude and partially purified amino of infection. The methodology to conduct this experiment first we have to extract the enzyme from the brain of the catfish. Then we have to perform partial purification using amino sulfate precipitation. For this, the green and Hirsch table is very important because if you want to make concentration of, for example, 0 to 20% at 20%, we have to refer to this table to know the amount of salt needed to be added to make the concentration. And then we also going to say the storage temperature. In this case, we're going to store the food and the purified at very different temperatures. And then we're going to evaluate the enzyme activity for 4 weeks. And then we do IC50 determination. For this, we use the food and partially purified fraction. And then we will use the calculator that is the night to get the IC50 values. And then we do test on vegetable sample that I will explain in the upcoming slides. Okay, for the results and discussion of preliminary experiment shows that partial purification is enough to increase the sensitivity of the enzyme towards pesticide. So, amino sulfate precipitation was chosen as a method to partially purify the enzyme because of its excellent solubility and inexpensive cost. Okay, let's look at the table 1, the purification table of the acetic cholesterase. We can see the highest enzyme activities were detected at the fraction 20-40% with a value of 85.66 units. So this 20-40% will be used for the IC50 detection, and also for test on multiple sample, we'll be using this method. Okay, then we'll talk about the stability study. So basically, research has shown that lower temperature can improve the enzyme stability, and that's exactly very good. Looking at the bar one, we could see that the crude and the partially purified fraction is stable for shows a better stability of oils at a much lower temperature, which is -20 degrees Celsius, compared to the higher temperature, which is 4 and 0 degrees Celsius. And then we talk about, and then we're going to look at the IC50 determination. Okay, for this, we can see the crude and partially purified IC50 reading. Let's focus at the carbofuran section, where we could see the IC50 values for the crude is 0.3042. It's much more higher when we compare with the partially purified value, which is 0.07228 milligram per liter. So why the crude gives a higher IC50 value compared with the purified meat? Because crude actually contains a lot of protein that enable pesticides to bind non-specifically. That is why there's less quantity of pesticide to the acetic cholesterase. So the main purpose of partial purification is basically to increase sensitivity of the enzyme towards pesticide by removing all the unwanted proteins. Okay, then now we're going to compare our study with the commercial source that we have today. So when I talk about, when we look at the benzyl carb, we can see that our source is much more sensitive towards benzyl carb with a non-overlapping confidence interval. And also carbaryl is also more sensitive to carbaryl with a non-overlapping confidence interval and the IC50 value, which is much more lower. Whereas for carbofuran, I would say both the commercial source and also the source from partially purified from this study gives exhibited similar sensitivity towards carbofuran. And then for metabolol, basically, because it's much more sensitive to metabolol compared to partially purified therapeutics. But proportion was not detected by the commercial source, but was detected from the study with a value of 0.0413 milligram per liter. So these are all categories of carbohydrates. Now, the same table, when we look at the chlorophyrus, thiazole, maltodextrin, and parathions, they are categories of organophosphate, and it didn't display any values of 25% confidence interval. Why? Because organophosphate, it can't be an efficient inhibitor of acetic cholesterase by its own. It needs to undergo bioactivation in order to become inhibitor. So in vitro, in laboratory, we have to activate it using globin water, which was not done in this research. That is why we will not be able to detect the values in this study. And then when we look at bar chart, okay, this is a test of vegetable sample. So when we look at bar chart 2, we can see as the volume of sample increases, the absorbance for tomato and cabbage, which comes under the category of acetic cholesterase, reduces. Okay, same goes to bar chart 3. Okay, but this is for partially purified. This is under partially purified cholesterase. It also shows a reduction in the absorbance compared to the crude, but the reduction is much more obvious or better. Inhibition was detected in partial purified, which is partial purified acetic cholesterase in bar chart 3 compared to bar chart 2, because when you perform partial purification, normally it will increase the sensitivity of the towards the toxic end by removing all the proteins. That is why partial purified fraction gives a better inhibition to pesticides compared to the crude. So so for the conclusion, so based on IC50 determination, we could see that local source can detect more types of carbohydrates with a higher sensitivity compared to commercial source. And this also suggests that local source can be a new source to replace the commercial source that acetic cholesterase that we have for biomonitoring work. And also, when we do test vegetable, it shows that partially purified cholesterase gives better inhibition more specific compared to food. And since organophosphate is not able to show any inhibition the aspect rises activity in the study, I would suggest other local sources should be screened to detect this compound. And if you also use local source to detect other types of toxicity, example detergents or azo dyes, and if you use liquid chromatography and mass spectrometry in future studies to identify potential pesticides in chlorhydrin. And this will be my reference. And thank you.
Hello, Pashmina, you just go to your slide number 10. Can you go to slide number 10? Just let me, I just, next one. 11, yeah.
Okay.
Crude and partially purified fraction, total protein and total activity of crude is higher than your purified, it looks, no?
Yeah.
So, okay. Anyway, your results are different, but here something crude is showing higher activity. Anything you can add to this one, or it was oversight, or?
Actually, I just knew that the flow is supposed to increase. I thought that was the mistake.
Okay.
The flow is supposed to increase, but it didn't increase in the study because I didn't add any protein inhibitors that could, that could result in the protein of enzyme. And also, for this study, we don't really require a highly purified enzyme because we do have the process showing that partial purification itself is enough to increase sensitivity. So we don't really require a highly purified enzyme for this study. That's what I.
Okay. Anyway, you look into that one later. Okay. Anyway, nice. Thank you. Toshi.
Okay, thank you.
Thank you, Tashmita. Next I call upon Bilal Ibrahim Tania. Sir, are you there?
Yes, I'm here.
Yes, sir. You can share your screen.
Okay.
Now, Sally, there was a computer, it was overheating. That's why he was offline during his presentation.
Who is presenting now?
Hello.
Hello.
Can you see my slide?
Yes, sir. We can see your screen. You just present your PPT.
Can you see it now?
Yes, sir. We can see it. Just make a full screen. Okay, you can start it. Can you introduce yourself and then start the presentation?
Yeah, good afternoon, good evening, Mr. Chairman, the organizing committee of this conference. My name is Bilal Ibrahim, and yeah, I'm a postgraduate student of University of Putra, Malaysia, under the supervision of Prof. Yunus. I would like to present on the topic, Tryptophan enhanced nano-zero-valent iron for the adsorption of conglomerate dye. Some of the collaborators we work on this research is Prof. Yunus, Dr. Adila, and Dr. Muhammad Khalizan. These are my contents, the abstract, which I'm not going to go deep into. Introduction, experimental design. Under the experimental design, we have this synthesis and up to isothermal analysis, and then conclusion, and then finally we have the references. This is the abstract. This is the introduction. Color has attracted humans, whether from an aesthetic or social one, and the primary source of creative resources, that is color. Color has been the primary source of creative resources, and dyes are coloring chemicals that are generally used to color items in the textile, rubber, cosmetics, and so on. Because of their low price and availability, it is available in a wide range of brand colors and simplicity of manufacture. This explains why dye is in demand in recent decades. But however, waste of textile production is considered the most significant polluter of pure water. That is why there is a lots of engagement in trying to manage dye influence from waste from textile and wastewaters. One of the most important or the most toxic dyes is congolate, which I'm going to talk about now. The 1-naphthalene sulfonic acid, which is one of the most regularly used dyes. It is significant, according to reports, a significant quantity of congolate dye is used in the textile, rubber, and so many industries. It has so many environmental and health issues. Example is cancer and so many issues. One of the methods that is used in remediating this dye is adsorption. And one of the material that is used is zero-valent iron, which is a promising emerging technology due to its surface area, relative cost effectiveness, ease of transportation, and so on. So if this adsorbent is very important, additionally, there is if it is enhanced, it is going to be a very important aspect. So additionally, enhancement with chitosan increase its applicability. This is congruent structure of congruent, and this is the chitosan. So before we go into the experimental design, we tried as much as possible to screen some dyes to see the the chitosan enhanced zero-valent ion applicability towards these dyes. So we screened these dyes. We screened about 10 dyes. So among all these dyes, congolate was the most significant, with the most dye that we have significant results. It has 97% absorption when we use chitosan enhanced zero-valent ion. So this is the experimental design. First, we try as much as possible to synthesize the material. From here to here, just the synthesis, and then after the synthesis, we characterize the material based on PSM, TEM, XRG, zeta potential, TGA, BET, FTIR, Roman. And after that, we went into batch adsorption optimization analysis, where we compare the effort and RSM to see which one has which is the best optimizing parameter. Then after which we went into kinetic and isotherm analysis and the error function. We try to determine the best fit out of the kinetic models and then isotherm models. This is the method we use in synthesizing chitosan and zero-valent ion. First, we used sodium borohydride, water solution added, and then we up to the stage where we mix the mixture, study it using shaker for 40 minutes, and then the sediment washed with oxygenated water and ethyl alcohol for 3 times. Then it was dried for 50 degrees under vacuum for 24 hours. This 50 degrees, it is normal. We can at some point we increase it to 60 degrees. And then after which we use magnet to separate the 2 layers. And then the material chitosan enhanced zero-valent ion was procured. After this, we went into characterization. We use FSM with emission scanning electron microscopy. We got FSM and we get that is before adsorption and after adsorption. That is before absorbing it with congolate dye, and then after adsorption with congolate dye. we use spectrophotometry at the wavelength of 610 nanometer to see the absorption. So we conducted SM, and then we conducted FTIR spectral characteristics of this material before and after. At this point, there is this band, the band at 462.3.39 here, which it explains the weak band of iron, because there is iron inside this. The method we use here, we use iron fluoride. So presence of iron weak band, the parent of which this 462.36 band represents a weak band of iron. That is the FTIR. So also after the absorption, this is after absorption, and this is before absorption. So the same band appears. At some points, there exist no bands that there are no bands that repeated itself. Then we did elemental analysis in EDX micrograph of.
So your time is up. Can you go with the conclusion?
Okay. We also use characterization of a TGA, and this is TGA, this is XRD and Raman. And then the temperature. We also did this offered at different temperature and time intervals. We use the kinetic, we use pseudo first or second order, and then we use the kinetic, the ISSR models. In conclusion, PSM and PM micrographs showed the potential of adsorption site as the tryptophan band come to the zero valent iron nano particle gas, enhancing its absorbability. The tryptophan which demonstrated a high thermal stability also showed a relatively high carbon content during the elemental analysis with a considerable amount of surface area, and thus making a high potential if efficient adsorption. Appearance of crystalline chitin peak at the XRE also demonstrated that this ion is successfully loaded onto it. Additionally, the rate of potential results explains the stability of tryptophan enhanced zero valent ion and justifies the availability of Mukonga read by the investigator. Effectiveness and reliability of tryptophan enhanced zero valent ion is in the adsorption process, which is one of the most effective, less expensive method of dye removal was explored. Now, finally, in conclusion, the performance of this tryptophan enhanced zero valent ion, which was investigated, reliably suggests its absorbability and applicability on other dyes. This is my references based on the literature.
Okay, Bilal. Thank you very much. You just tell me what is the color of nano zero valent ion?
Nano zero valent ion is red because of the contents of the ion.
Is it red?
Yes.
Because of?
Because of the presence of iron. It's red.
No, I'm not getting you.
You said what is the color of nano zero valent ion, right?
Yeah,
it's red in color, like maroon. So we use it with tryptophan.
But are you sure it's zero valent? Because iron gets color only if it is oxidized to plus 2 state or plus.
2 plus what?
It gets color only when it gets oxidized. So I'm just asking you. So it should not be. It should be metallic color. It should be metallic, shining. That's what I expect.
It is red, but it is shiny.
No, red. The moment you say red, no, it means it is not a zero valent.
what I mean is when we try to calculate
Color is due to what?
is due to
Color of any
iron
material.
oxide. Iron oxide.
Iron?
Due to presence of iron oxide. When we
Iron oxide. Then it's not zero valent. If color is because of iron oxide, then it is not a zero valent. You understand, Bilal?
okay.
It must be oxidized state only. So it's not zero valent. You just check it.
Okay.
And once you add titration to that one, what will become the color? Again, same red, isn't it?
When we add titration,
With the titration,
no, it's not red. It's blackish.
it's a black.
Yeah, black.
Okay, okay. Anyway, you have to just check whether that is the zero valent ion you are achieved or not. Because your synthetic process doesn't tell me that it can go to zero valent. Anyway, you just check it. You are a research scholar, you can still you have time to do. Okay? All the best.
Okay. Okay, thank you very much.
Thank you, Mr. Bilal. Now I next call upon Ibrahim Yusuf.
Okay, thank you.
Can you hear me, Mr. Ibrahim? Hello, can you hear me, Mr. Ibrahim? Mr. Ibrahim Yusuf? No, it's not there, I think. And now I call upon the next person, Mr. Abdullahi Fago.
Okay. Okay, no?
I can hear you, sorry. Hello?
Hello?
It's Ibrahim, I can hear you.
Ibrahim, so Mr. Ibrahim, you can give your presentation.
Okay. Can you see my slide now?
No, sir. No.
Okay. Yeah, can you see it?
Yes, sir, we are. No. Yes, sir, we can see it.
Okay. And Ibrahim was talking to my name. It was graduate students. It was graduate student at University of Futra.
Hello?
Hello. I said I'm Ibrahim Yusuf talking to my name. It was graduate student.
Ibrahim, just a minute. Ibrahim, please.
Yes.
You can go with the full slideshow view.
Yes, I'm on the slideshow now.
Yeah. And you are having only 8 minutes. Please try to conclude your presentation within 8 minutes, okay?
It's all right. So,
can you introduce yourself once again?
Professor
Mr. Ibrahim?
And yes?
Can you introduce yourself once again, whether you are a UG student, PG student, or a teaching staff?
Okay, I'm Ibrahim Yusuf talking to my name. It was graduate mobility student at University of Futra, Malaysia.
Yes, you can continue it.
Yes, and the co-authors of this research were Professor Yunus bin Abdishakur of University of Malaysia and Professor Ahmad Sheikh of Federal University, Duse from Nigeria. One of the major global problems of serious concern are pollution of heavy metals, and these heavy metals are always being released from industries to the drinking water. And industrial effluents were found containing significant amount of heavy metals like lead, copper, chromium, and others, and many others. And coupled with the industrial effluents release, we still have domestic and agricultural activities that are also contributing to the release. Now, heavy metals, unlike organic solvents, are non-biodegradable. As such, they concentrate and accumulate within the body of living organisms through food chain. And their accumulation are distorting the DNA conformation and also resulting in several health hazards like cancer. Now, fungal diversity usually is usually affected by a number of factors, some of which involve concentration of these contaminants. And this research is to determine the effect of these contaminants of fungal microflora. And the research, this is because researchers are now advancing toward biological means of controlling or remediating heavy metals. And fungi is one of those that are showing a very promising result, and that is why we want to evaluate the diversity of this microflora so as to have an insight on the kind of fungi that will be employed for the remediation activities. Now, increasing in domestic activities resulting in further release of this effluent, and the effluents are mainly being discharged from pharmaceuticals, tannery, textiles, and so many other industries, apart from the agricultural activities. Now, heavy metals are having a lot of tendency to accumulate within the body, and these heavy metals, like I said earlier on, are non-biodegradable. Now, hello? Okay. Now, the accumulation resulting in a lot of diseases or health hazards. And now, fungal growth is significantly hindered by higher concentration of heavy metals, pH and salt concentration in most cases. So despite numbers of reports on bioremediation, microremediation of different fungal species, of different fungal species, of different fungal, report on fungal bioremediation. Now, there is very insufficient documented work on the study area. So the study area is going to be Kano State, Nigeria, and is located between the latitude of 4 degrees and 14 degrees north and latitude 2 and 15 degrees east. And Kano is ranked as the first populous in terms of human population, and it's second largest in terms of industrial activities. And the pharmaceuticals, tanneries, and chemicals and allied textile industries divide the city, the two main rivers of the city, into two groups. And most of the domestic activities using water are relying on those water bodies. So that is why the research is too important. Now, this research, we employed a completely randomized block design because of the factors that we have involved. And in sampling sites from all the three industries, the tannery, pharmaceuticals, and also the textile, we collected samples, effluent samples from untreated water channels, water retention ponds, discharge points, and combined drainage. Composite samples of each place were collected in 2-liter capacity containers, sterile containers, using purposive random sampling. And then the heavy metals were determined using atomic absorption spectrophotometer at the General Laboratory of Soil Science Department, Medical University Zaria in Nigeria. And then temperature and pH were taken in the site of collection. Now, the media used for fungal identification is the photodextrose agar and was prepared according to manufacturer's instructions. Samples were allowed to stand concentrate by sedimentation at room temperature, and then about 50% of the samples were discarded. Then the content is 10 mils were centrifuged at 250 RPM for 10 minutes. Then 1 mil of the 0.1 mil of the aliquot was suspended onto the growth media for incubation and for culturing. Now, few cultures were used in identification, and this part of the research, because the research is still ongoing, we use micromorphological characteristics using lactophenol cotton blue and microscopic method of identification. Then the percentage frequency of occurrence of the fungi were obtained using the formula that you are seeing on my slide. And then the Simpson index of diversity and Simpson diversity index were also used to determine the abundance. Now, okay. Now, what you are seeing, here is the results of the heavy metals that were. Hello? Hello, can you hear me?
Yes, sir, we can hear you.
Okay. I said the result that you are seeing is results from the heavy metals that were isolated and their concentrations. As you can see from what I'm presenting, we have about 6 of them: chromium, cadmium, copper, iron, lead, arsenic, and arsenic. And arsenic said to be of higher concentration, as you can see, and it's obtained from the pharmaceutical industries, and it's having about 30.47 ppm, followed by another arsenic from Tenerife, which is having 23.58 ppm. And then the list is 0.3 from the same pharmaceuticals.
So your time is up, we can go with the conclusion part.
Okay. Now, okay. Okay, the next result I'm having here is. Sorry, I'm coming.
Hello?
Hello, I'm coming, please.
Sorry, sir, we are unable to hear you. Your voice is not clear.
My voice is not okay. I'm having issue with the slide.
Okay, sir. Orally, you can complete your presentation.
Yes, I can do that.
Okay, sir. We'll move with the questions now.
Okay. Sorry. Here I have the.
Okay, Ibrahim, don't worry, relax now. Yes, relax.
Okay.
We understand whatever work you are planning to do. Okay. You have chromium, cadmium, lead, arsenic, and mercury probably. Yeah.
Yes.
So, that is what the test solution you have taken from the outside wherever the effluent is there. Correct.
Yes.
Okay. Suppose you have prepared your own effluent at your laboratory with chromium and lead. Okay. Only 2 elements, chromium and lead. Okay.
Yes.
And you use whatever fungal thing you are using, which will be efficiently removed.
Pardon?
Which will be efficiently removed, whether chromium or lead.
Well, I won't use both, but from what I'm having, arsenic is having higher concentration, so I want to also involve arsenic in the remediation.
No, you have a test solution of only chromium and lead, only 2. Which one will be removed faster?
Well, I didn't carry out
okay, you didn't try. Okay, fine.
the remediation.
What chemistry says? Chemistry has to do.
So I don't know. I'm presently working on the chromium, and it's showing something promising.
Okay.
Because the result is not up to, it's not concluded, so that's why.
Okay, don't. I understood. Okay, fine. Okay,
Yes.
okay. All the best.
Thank you, sir.
Thank you, Mr. Ibrahim. Now I call upon Abdullahi Fago.
Okay, thank you, and I apologize for the technical problems.
Okay, no problem, sir.
Yes.
You can stop your presentation now. Yes, the next one is Mr. Abdullahi Fago, can you hear me?
Yes, ma'am.
I request you to start your presentation.
Okay, thank you. I'm trying to share a slide.
Okay, sir.
So I don't know if you can see my slide.
No, sir, not yet.
Okay. Is it visible now?
No, sir, it's not.
Okay. But it shows that I have already started sharing. So let me stop the sharing and share again.
So you just open your PPT there.
Yes, I did that.
But I'm sorry, it's not visible.
Okay, I'm trying. So can you be able to see my screen?
Yes, sir, we can see your screen.
Okay, thank you.
Yes, sir. You can start with your slideshow. But please introduce yourself. Thank you.
And I'm presenting on the section of reactive block 5, the inactivated
Sir, excuse me, sir. Sir, can you introduce yourself?
Yes, I'm Abdullah.
Please try to finish it in 8 minutes.
I'm a PhD student here in University Putra, Malaysia, under the supervision of Prof. Yunus and the co-supervisors.
Sir, can you go for a slideshow, please?
Pardon?
Yes, sir. Click it there. Okay. Yes, sir. You can start it now.
Okay, thank you.
Sir, can you go directly to the results?
Okay, so
we are actually in the shortest time. Can you go directly to the results?
Yes, it is interesting that the previous presenters have laid a good foundation on the problems as well as the justification as to why this work is relevant. So I will skip to this, but an overview is just I will open on the active block 5, which is even in a minute concentration is very, very toxic, and various methods that have been used are not effective. So bioabsorption is one of the promising methods as suggested by different literature. So these are the problems, the justification, the aim, and the overview of the method. So we isolated about 10 organisms and we tested them. As you can see, these are the overview of the organisms, ground reaction and the number of isolates, and as well as the location. So we screen the bacterial isolates, 10, but here you can see it. So we screen 10 isolates. For the various dyes, we have about 14 dyes. Out of that, we found that the most significant result was found on the reactive block 5. It shows a promising result, and as such, we also screened the reactive block 5 using the isolates, and we found that isolate S23 was having the best result. So because of that, we selected such organism for further experiment. So this is some of the morphological structure of the F23 as well as one of the isolate S1. As you can see, it is gram-positive organism. So as you can see in the methodology, gram staining as well as the genomic DNA extraction and the PCR was conducted. So this is the summary of the phylogenetic analysis, and it's related to bacillus species. So the summary of this, my work is basically on biosurfactant, which we use the bacterial solvent for the reactive block 5, as you can see. So after adding the organism, it was agitated And at the various time interval, we used to take the readings and centrifuge. After the centrifugation, we will examine the observance using spectrophotometer. So after we have gotten the best isolate and the best dye, we move into the next step, that is optimization. So for the sake of this presentation, I'm only presenting on the two objectives alone. And other work is still ongoing. So we optimized this process using one factor at a time. In this case, we kept all other factors constant while varying the factor in cluster. So as you can see from this result, we consider the result for the effect of agitation on the bioversion of lactic blood 5. And from the result, you can see 60 RPM was found to be the best. And here is the illustration of the dye as well as the biomass before the adsorption. And you can see the change in color or the reduction in the color intensity after the bioabsorption as compared to the control. And the next factor is the contact time. We check on the effect of contact time, and we found that the absorption is gradually increasing across various time until it reaches maximum absorption capacity at 180 minutes, and after which the absorption drastically reduced. And the next is the effect of absorbing dosage. As we know that the quantity of the biomass or the absorbing material affect the absorption process. And as absorption, it has been said that as the biomass concentration increases, the absorption also increases. So it is in tandem with our work. As you can see, the highest absorption was achieved at 0.175 gram. That is the highest absorbent dosage we use. And as you can see, this is before absorption, when we added the biomass, and after absorption, you can see a reduction in the intensity compared to the control after absorption. So then we also check the effect of temperature, and it has been found that at 40 degrees Celsius, the maximum absorption capacity was achieved there, and at higher absorption, it increases the interaction as well as the kinetic energy of the biomass, and hence in the absorption. So you can see this is the control as well as the best temperature used. These are the various temperatures used, as you can see. So the next factor, which is the most important factor, is the pH, which is found to influence the absorption capacity. And from the literature, active dyes mostly are very, they will actually achieve absorption, higher absorption at acidic pH. It is in tandem with this work. As you can see, the maximum absorption capacity was found at pH 2. And it might be due to the proliferation of the functional groups, which forms improve the absorption capacity. So this is before absorption. You can see the intensity is very high, and after absorption, it reduced. And specifically, these are the pH 2. So compared to the control here, you can see the maximum reduction. So the next, we consider the effect of initial dye concentration, which is also very, in fact, influencing the absorption. So we find that as the concentration is increasing, the absorption capacity is decreasing. So this will be due to the saturation of the biomass of the early state of absorption. And maybe from the literature, at least some of the organisms favors absorption at low concentration of the initial diet concentration. So in conclusion, it can be said that about after isolating the organisms and tested, the best isolate was Bacillus cohesius 2-3, which had 50% absorption capacity. So on optimizing this absorption conditions using OFAC, the inactivated Bacillus improved suction capacity to 87% 12 pH to 40 degrees Celsius, 5 milligram per liter of initial diet concentration, and 0.175 gram of the absorbent dosage, 60 revolution per minute as the agitation, and 180 minutes. So it indicates that the potential of inactivated Bacillus species for the treatment of direct polluted water. So my recommendation is, even though as part of this work we have conducted, you consider the chemical modification of the biomass. We tested the HCl, sodium hydroxide, acetate, and other chemical modifying agent. So further experiments should focus on the immobilization agent because as bacteria, Abdul Samad in his recommendation, he gave the regeneration of the biomass. So we can see that immobilization will help in the in improving the regeneration capacity because bacteria is not very strong. Regeneration will not be efficient. It is not efficiently immobilized. So thank you for I thank Prof. Yunus for his supervision as the host institution for the sponsorship. Thank you. These are my selected references.
Okay, Mr. Favo, very good. I just wonder why that 60 RPM is unique.
Pardon, sir?
Why that 60 RPM agitation? Why so specific it is?
Yes, this is a very good question.
Is your observation? Yeah.
As we can see, agitation affects the contact between the solvent as well as the absorbent.
Yeah.
So at some point, when the agitation is at very high, the interaction between solvent and the adsorbent may not be efficiently well. There may be repulsion. But
Okay. Yeah, fine. One more question. Now, before you, there were 6 people or 7 people all presented on bio absorption. Okay. So what your universe is almost all 6 presenters who were before you presented, use biomass only. Correct?
Sir, I cannot get your question. Sorry. Can you take it again?
Before you, there were 6 or 7 presenters today who worked on the bioabsorption. Correct?
Okay.
So, yes. Yeah, what were your processes superior or at par with those things?
Why?
Why whether your process is better than those people or yours is better?
Okay, maybe you want me to compare my result with that of the previous presenters? So what I can say is, as we understand that the nature of the biomass, the bioabsorption actually is involved between the adsorbate and the adsorbent. And these different biomolecules or heavy metals have different absorption capacity. Likewise, the different biomass used, either bacteria, fungi, even within the bacteria, positive and gram-negative. So the differences that may be found with my result and theirs
might be due to the nature of the biomass used and the nature of the dye used. So I
Okay,
think
okay,
this is-
nature of dye and also, okay, fine. Fine, very nice. All the best.
Thank you, sir.
Thank you, Mr. Fago. Now I call upon Mrs. Aruna Sudami. Ma'am, can you hear me?
Yes, thank you, ma'am. Yes, ma'am, I'm here.
Okay, ma'am. You can go with your presentation, please.
Is it visible my presentation, ma'am?
No, ma'am, it's not visible.
It's not visible. Now, ma'am?
Ma'am, it is getting. Yes, ma'am. Yes, ma'am. We are able to see your presentation. Just start your slideshow and try to finish it in 8 minutes, please.
Yes, ma'am, yes. Yes. Is it okay, ma'am?
Yes, ma'am. It's okay.
Okay, okay. Good afternoon, everyone. I'm Professor Aruna Sudami from Raisoni College of Engineering, Nagpur. I'm a faculty as well as a research scholar in this college. And I'm going to present here on my research topic, that is removal of toxic, that is metal chromium 6 from wastewater by using waste tire as adsorbent. Well, why I choose this is a waste tire as a adsorbent. Nowadays, you can see that because of globalization or because of the automobile industry, the production of that tires increases very much. And this is a number which can be increased day by day. And in the coming years, even we can predict that 2030, the number will be around 1.2 billion. So because of this one, definitely it is harm to the environment, not only in the environment for the air pollution as well as the water pollution is also there. So actually, this is idea behind it for taken as a, this is as a absorbent from waste tire. Both the things are there. One thing is that to minimize the waste, which is that is a waste tire, and another is that is to give some sustainable solution for the water. Because there are the number of methods by which you can minimize or you can absorb by the different metals. Maybe adsorption, maybe ion exchange, maybe reverse osmosis. Number of methods are there. But this is the by using this is the best tire as an adsorbent, the very best adsorbent because it's a cheap available because we don't have to take any for that, and with this one we can minimize the waste also. Okay. So while addition we are done, actually targeted 2 to 3 metals are built. I already done the work with the chromium, and the next work which is already going on, that is about the lead. This is the work done. So we already prepared this 100 ppm and 50 ppm concentrated solution of chromium, and we carried out at the different by weight 0.5 and 1 weight per percent of adsorbent. And we evaluated with respect to time, pH, and concentration like this one. Now we carried out with the help of that is index to that is coupled plasma spectroscopy, and we got it standardized it and lambda wet parting that at 180 concentration for the 100 so here we can see here around at at 90 in late, we got a higher, that was 50.2. Of course, this is not the very best result. In this slide, I will see what we are doing for the good result. And for the 100 people, with the 1% I did, so here we got at 90 times, we got around 2.5. So there is a difference. And for the weight per we got 60.5. Then this is the graph for the same result we calculated it. And here we can see here that is at highest at one time 90 is here. So we got this one. At 50 we got like this one. In the next concentration we prepared at 50 ppm. In the previous at the 100 ppm and here is the so here is also for fine weight down at 58.8 and here her weight around 8.8. So we got pH. So for pH we got at 3 pH is occupied. So actually the at basic pH that this is a work very nicely. And actually I got it around at 3 pH around 84.4. And for the concentration, so once you have to increase the concentration, so of course the efficiency or the absorption of that particular substance is going to be increased. So I was at 2 around 1.592 equals K is around the 60% efficiency. Now actually this result, of course the results are not that's why I got evaluation with the zinc oxide, and again there is another that is some nano particles to be converted to activated carbon, and then after that again I gone to the procedure and again I got the result about the around 80 to 85 there. So this is the result. So at higher concentration, 10 ppm efficiency should be achieved only 60%. Only at the activation with the zinc oxide, that my result is definitely increased. And with result, of course, I can give the that 100% efficiency, but 80 to 90% efficiency can be increased. Okay. These are the references. Thank you, sir.
Thank you very much. Just let me know, you are using only chromium, isn't it? Hello? Can you hear me? Hello? She left.
So can choice.
Oh, he is waiting. She has left? Okay, thank you.
Then one more person is there, no? He's one more person.
Next, I call upon Mrs. Dr. Rakhi Khandelwal.
Yes, ma'am, I am here.
You can go with your presentation, ma'am.
Yeah.
Hello?
Is it visible?
Yes, ma'am, it's visible.
So, just a minute.
Hello?
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 So you want to ask a question?
Ma'am, am I audible?
Yes, ma'am, you're audible.
So can I start my presentation?
Yes, ma'am, you can start your presentation.
So first of all, good evening to all the esteemed members present here. I, Dr. Rakhi Khandelwal, Assistant Professor, Government Minor Engineering College, Neer, Rajasthan, presenting my research work on biomedical applications of green synthesized silver nanoparticles. So before starting the presentation, just have the look at the outline of my presentation, which includes introduction, materials and method, characterization, biomedical applications, and conclusion. So first is the introduction. Before starting this research work, we have three main questions in our mind. One, why the silver nanoparticle? Second one, why the green synthesis method? And third one is the plant which we have chosen for the synthesis, that is Bacillus vulgaris. Why we have chosen this plant? So the introduction part includes answer of these three questions. First is the importance of the silver nanoparticles. We know that due to the peculiar optical, thermal, electrical, and biological properties, silver nanoparticles have been used for several applications, which includes human healthcare, cosmetics, water treatment, textile, imaging, and biosensing. So that is why we have chosen the silver nanoparticles for our study. Now, second question is why we have chosen the green method. Traditionally, the synthesis of silver nanoparticles involves four chemicals mainly, that is silver nitrate, reducing agent sodium boron hydride and potassium bromide, and the stabilizing agent sodium citrate. But in the green synthesis method, these three chemicals are not required. In place of these three chemicals, only the one chemical, that is the plant extract, is used. So, in the green synthesis method, it is an eco-friendly, cost-effective, energy and time-saving method. Secondly, it can be easily manageable and exposure on a large scale. That is why we have chosen the green synthesis method. Now, for this green synthesis method, we have selected the raw material plant extract to synthesize the silver nanoparticles. And the plant Bacillus vulgaris we have selected for this purpose. Why we have chosen this plant? Because this plant is easily available at a nominal cost. It is edible and has no toxic constituent, which make it suitable for the preparation, so that the synthesized silver nanoparticles can be used for medical applications also. The phytochemicals present in the extract act as a reducing agent as well as the capping agent. So, no other additional chemical is required in this synthesis process. Now, coming towards the second part of my presentation, that is synthesis of the silver nanoparticles. Here I have discussed that only two chemicals, precursors are required in this synthesis. One is the plant extract, second one is the silver nitrate. So, to prepare the plant extract, we have chosen the seeds of Bacillus vulgaris, grinded the seeds in the crusher, and then prepare the plant extract. Now, for the synthesis process, the plant extract is mixed with the silver nitrate solution in 1:10 ratio, and then solution is mixed. After some time, we have seen the color change in the solution.
Excuse me, ma'am. Sorry to interrupt, but your screen is not moving. We are not going to the next slide.
Okay. So from which side I have to repeat, ma'am?
No, ma'am. Don't repeat it. Just show your slides till what you have finished.
Now it is visible, ma'am?
Yes, ma'am. It's visible. You can continue.
Okay. So sorry.
Okay. No problem, ma'am.
No. So synthesis of silver nanoparticles, when we mix the silver nitrate solution with the plant extract, the biomolecules of phenols and flavonoids present in the plant extract reduces the silver ions in the solution to the silver atoms. And the proteins in the plant extract actually helps in the reducing the agglomeration of the silver particles in the solution, which helps in the formation of the stable silver nanoparticles in the solution. After the synthesis of the silver nanoparticles, we are coming towards the characterization of silver nanoparticles. For the characterization, three characterization techniques we have used, that is UV visible absorption spectroscopy, FTIR spectroscopy, X-ray diffraction measurement. In the UV visible absorption spectroscopy, actually I am not in slideshow mode, so any difference is not shown. Thereby, these overlapping slides are visible. I am sorry for that. For the UV visible absorption spectroscopy, we concluded the conformation of the silver nanoparticles formation. Second is the symmetry is less than the spherical, because the SPR band is found is very broad band. That is why we have concluded this. From the FTIR analysis, we have concluded that the silver nanoparticles, in the formation of the silver nanoparticles, here is the involvement of the phytochemicals present in the plant extract. After that, we have performed the XRD measurement. The XRD measurement concluded the crystalline nature of the synthesized silver nanoparticles with the cubic structure, and the particle size from the XRD data we have calculated is 15.76 nanometer. After characterization. We have studied the biomedical applications. We have studied two biomedical applications, that is antimicrobial activities and anti-cancer properties of the synthesized nanoparticles. The antimicrobial activity of synthesized silver nanoparticles was studied against three bacterial strains, that is Pseudomonas aeruginosa, Staphylococcus aureus, and Klebsiella pneumonia. For these, all the three bacterial strain, we have found that the synthesized nanoparticles are very effective to reduce the growth of these bacterial strain. Next, we have studied the anti-cancer activities of the synthesized silver nanoparticles. The anti-assay results for synthesized silver nanoparticles against the human breast cancer and hepatic cancer cell lines are shown in this table, and we have clearly seen from this table that presence of the synthesized silver nanoparticles effectively reduces the cell number of the cancer cells, which indicated that the presence of silver nanoparticles reduces the rate of cell proliferation of the cancer cells. That is why we concluded that these synthesized nanoparticles show potent cytotoxicity against the tested cancer lines. Now, coming towards the conclusion part, from our studies, we have concluded that this approach produces silver nanoparticles in a clean, non-toxic, eco-friendly, cost-effective, and efficient manner at room temperature without any additive. The silver nanoparticles were successfully synthesized with the particle size of 15.76 nanometer, and the crystal structure of the synthesized nanoparticle is cubic. So, we have successfully synthesized the stable silver nanoparticles following the third and ninth principles of the green chemistry. The silver nanoparticles kept with the phytochemicals can easily penetrate the bacterial cell and inhibit their growth, hence showing good antimicrobial potential. The phytochemicals helps to improve the susceptibility of the cells to silver nanoparticles, and due to the nano size, increased surface area improves the penetration of the silver into the bacterial cell. Secondly, the nanoparticles show potent cytotoxicity against the human breast cancer cell and the ovarian cancer cell lines, because the silver nanoparticles were synthesized by edible plant seeds and are kept with the phytochemicals of these plants. Therefore, these green silver nanoparticles may prove to be more susceptible for human body, and when targeted on the cancer cells, then inhibit their growth. So that's all for the conclusion. These are the references. I express my immense thanks to UGC CSR Indore Center for providing financial assistance for this research work and for providing UV visible substance spectroscopy and XRD studies facilities. And I am also thankful to Sri Ram Swarup Memorial University, Lucknow, for providing facilities for studies of the biomedical application. And I am also very thankful to the organizers of this prestigious conference for providing me the opportunity to join this conference virtually and present my work. So that's all from my side. Thank you. I hope I sum up within the time.
Okay, thank you very much, Dr. Rakhi. Silver nanoparticles synthesized by reduction method, yeah?
Yes, sir.
And also by using the plant extract, correct?
Yes, sir. Yes, sir.
Now, only one plant extract you have taken, or several different plant extracts?
Actually, I have taken 3 plant extracts, but I am presenting the result of 1 plant extract here only.
No, then only you can tell phytochemicals are going to give some reasons towards it.
Yes.
At least 2, 3. Yes. Anyway, but what is the size of the silver nanoparticle? Could you find out properly?
Yes, sir. From XRD data, we have calculated it 15.76 nanometer.
70?
15.76.
Decimal?
5.76.
It's a decimal. Okay.
Nanometer.
Okay.
15.76 nanometer.
What is the color of that silver nanoparticle?
Sir, which we have synthesized is reddish color.
Which one? With reduction method?
Particles.
With reduction method?
Yeah.
Reddish?
Reddish color, yes, sir. Starting a golden color, when we stay it for some hours, then it changes to the darker color.
Okay, okay. All the best. Thank you.
Thank you so much, sir. Thank you so much, sir.
One more presenter.
Last one.
Salihu Yahucha.
Salihu? Salihu is here? Online?
Then should I move?
Yes, Salihu. Before doing the presentation, you can leave the meeting.
Okay, thank you.
Salihu also is here?
Yes, I'm here.
Okay, I think you are fine with your connectivity now.
Oh, connectivity on the computer.
We can start with your presentation. Please share the video and video yourself and you can continue.
Okay.
Salihu, Yahuza,
Yes?
please share your slides.
I'm opening the computer. I'm on the computer.
You're on the computer.
Yes, sir.
Please can you make it fast? Because already you are late.
Yes, I'll make it fast. Just 2 minutes.
Yeah, make it fast.
Okay, sorry. I like to see my television.
Can you say is recorded video extra? And we'll assess you guys. Our success. We heard it.
Salihu?
Yes, sir. Yes, sir. I'm opening it now. Because they took up light and I own it now. I'm entering the link now. Oh my God. Yes, I'm joining now.
Yeah.
I'm joining.
Yours,
Okay. I'm sharing it now.
Yeah, please. Why are you stopping?
Can you see it?
No, no, let it, just, maximize it, please, yeah. Okay.
Yeah, can you see it?
Yeah, you can go with the full slideshow, please.
Okay.
Fine, you can start with the presentation. Fine, perfect.
Okay.
I think maybe you can start from where did you stop, please?
Yes, sir. Okay. I said the presentation is just on this outline. Can you hear me now?
Yeah, sure. Go ahead, please.
Okay. Textile industry, textile, paper, can, printing, and cosmetic industry discharge a huge amount of wastewater containing synthetic dyes. So most of these dyes are poisonous, carcinogenic, teratogenic, and can cause skin infection and mutation. They also impart color to the wastewater stream, thereby preventing sunlight penetration, which eventually lead to the decrease in photosynthetic process of aquatic plants. Bioabsorption is a physicochemical process that includes mechanisms such as absorption, adsorption, ion exchange, surface compensation, and precipitation. And it is an attribute that is exhibited by both living and non-living organisms. It is estimated that textile and manufacturing industries use more than 10,000 commercially available order, with the textile industry consuming more than 1,000 tons of dye per year. And approximately 10 to 15% of this dye is being discharged into waste streams as effluent during the dyeing process. Although physical and chemical procedures are utilized to remove dye, alternative approaches such as biological systems are required due to the limitations such as high cost, limitation application of dye types, and large-scale dumping of concentrated dye. In recent years, research has focused on the existence of organisms capable of removing various types of dyes from wastewater. Microorganisms like bacteria, fungi, and algae have been reported to be used as biosolvent in the bioabsorption of different types of dyes. In recent years, commercial biosolvents were developed by some companies for bioabsorption of metal ions. The companies include these advanced mineral technologies in Idaho, which use a new biosolvent called AMT Biochem, made up of bacteria from the genus Bacillus for dilute wastewater treatment and medical problems. And the other companies like Biorecovery System that is based in Las Cruces, USA, produce alga soap, which is an algal biosolvent made by immobilized gel polymer matrix. So problem statement, generally speaking, dyes have a negative aesthetic effect on wastewater, and some of them and their bio-related products are toxic, mutagenic, and carcinogenic. Synthetic dyes not only affect the quality of water due to their color, but also increase the biological oxygen demand and chemical oxygen demand, inhibiting the rate of photosynthesis and plant growth. Each year, millions of tons of dyes are produced globally. Wastewater containing dyes, when discharged to water bodies and water treatment plants, affect the ecosystem, thereby causing a serious health problem to aquatic flora and fauna, and in return, humans. Today, it has become crystal clear that dyes cause negative effect in all the ecosystem, and that reactive red 120 dye is particular concern to our health. Dyes, justification of the dyes dyes are such an important compound that resist by degradation and therefore require an alternative means for the removal from wastewater. Several researches have been carried out for the removal of dyes from wastewater, and sorption is considered to be comparable. Researchers have employed physical, chemical, and biological methods in dye sorption. Among the sorption methods, biological method is proven to be widely used because of its ease, cheaper, and eco-friendly. Microorganisms, particularly bacteria and their biomass, are considered to be the best candidate organisms for dye biosorption and are used as biosolvent in the bioremediation of dye due to their efficiency, low cost, and fast. The aims of the research is to see the screening of the biomass of Enterobacter MM05 that is responsible for the bisection of the active rate, and it could be achieved through the following objectives. Number one is to screen the bacterial biomass for the active rate 120 bisection. Number two, to optimize bisection condition using OFAT and the RSM. Third objective is to characterize the bacterial biomass using FTR and SEM. Fourth, to study the isotherm and kinetics of the bisection. And fifth objective is to study the effect of thermodynamic parameters on the dye bisection. This is the flow chart of the material and method. Start with the screening of the bacterial biomass and the dye, then optimization of the process using OFAT and RSM, then characterization of the biomass using FTR and SEM, isotherm and kinetic experiment, then finally thermodynamic experiment. So based on the screening method, the bacterial isolate was grown on nuclear dross and incubated on a rotary shaker at 150 RPM for about 18 to 24 hours. The biomass was extracted using certificate.
Sahili?
Yes, sir.
Can we go for the result and discussions, please?
Okay. So based on the results shown, this is the screening result, the result of the screening, how the isolate and the dye, how the bacterial isolate and the dye were screened. So of the 12 isolate number 2 showed the highest absorption on the reactive rate 120 dye. Therefore, it was selected for the experiment. These are the graphs that show the optimization of the different parameters like dye concentration, adsorbent dosage, temperature, pH effect, contact time, and agitation. So this is the result of the ISM using the placket Bowman design. Up to about 12 experimental runs at different at 2 levels, that is low concentration and high concentration of the parameters. The parameters are dye concentration, contact time, agitation, temperature, and adsorbent. And this is a percentage of the absorption based on the parameters. This is the table that showed the 3-level full factorial. After the PBD experiment, it was discovered that 2 factors were shown to be significant, that is dye concentration and adsorbent. Therefore, they were subjected to the 3-level full factorial design, and these are the actual and predicted value obtained. This is the 3D structure of 3-level full factorial that shows the relationship between the dependent and the independent variable. That is the response, the dye concentration, and the absorbent dosage. This is the result of the FTR analysis before and after the experiment. This is the interpretation of the FTR. The FTR is based on it was conducted in order to determine the functional group of the dye. This is the kinetic and isotherm experimental result that was conducted at different time interval and also different dye concentration, ranging from low to high concentration. This is a graph after the kinetic experiment. Then it was modeled. The kinetic model was conducted using the CAP expert software, and after the experiment, it was discovered that certain pseudo-second order kinetics fitted the experiment based on the error functions kinetic models, based on the error function result 10, because it has a low AICC value of about minus 39.091. compared to the pseudo first order kinetic that has minus 4.660. These are the graph of the isotherm models of the of this isotherm results. Isotherm models, it was discovered that the Leak isotherm has the lowest AICC value and is the best. Fitted the experiment based on the graph 10. You can see. This is the table that shows the thermodynamic experiment. The thermodynamic experiment was conducted using using 5 different temperatures.
Please open for conclusion part, please.
Hello?
Please go for conclusion part.
Can you hear me?
Go for the conclusion part.
Okay. So based on the results obtained, the delta G, delta H, based on the according to the table, the values are shown. In the conclusion, 12 different bacterial isolates were screened for the absorption of reactive rate 120 dye, and it was found that Enterobacter species strain MM05 biomass had higher percentage of dye removal. OFACs and the RSM optimization method were used to improve the process. This optimization method improved the dye percentage. It was discovered that the RSM optimization provided the most optimal condition for dye removal. The kinetics of bacterial biomass absorption on reactive rate 120 dye were investigated, and the dye was discovered to follow a pseudo-second order reaction. And of all the 8 isotherm models employed, that is hairy, Langmuir, Produlus, bed positives, Rosilda 4 and 5 in the isotherm studies, it was only hairy model that showed poor fitting result. These are the references. Thank you for listening.
Okay, just ask me. Hello. Can you give me show me the first slide, your title of your work?
Okay. Okay, title.
Title, yeah. Equilibrium kinetics and of the okay, reactive rate. Okay, then conclusion. We come to the conclusion. Okay, yeah. You have used 12 different bacterial isolates, isn't it?
Yes, sir.
12. Why did you use 12? What was the reason? Why did you use 12?
Okay, the 12 isolates were based on the experiment at that time in Malaysia. It was only available isolate from the lab because some isolates were used for degradation experiment, and for this one we tested them for bisection experiment.
Okay, all the best.
Thank you for the presentation. Thank you.
Thank you.
Okay, so dear participants, by this we have come to end of the oral presentation. So thank you each and everyone for the wonderful presentation. So we'll be signing off for today now. And again, we'll be joining tomorrow morning, 9 o'clock. Thank you very much.
Yes, thank you so much.